To the earliest observers, the cosmos was the realm of the gods. They controlled day and night, the passage of the sun and moon. So too the constellations and those wandering stars we know today as planets. Great monuments honored the gods, but such monoliths had a practical function. They were the first observatories, marking the rising and setting of the sun, the moon and the stars, a celestial calendar with which the ancients could measure the seasons and predict events. Thus was born astronomy. Today, this nightly progress of the stars is little changed from the view of those first observers. What has changed is our understanding. Myth has yielded to science. We know, for instance, that the band of light in this time-lapse isn't milk spilt by the gods, but an edge-on perspective of our galaxy. It's the Milky Way, home to the sun and all the stars we see in the night sky. One galaxy among the 50 billion thought to comprise the universe. Face on, the Milky Way is a spiral of some 200 billion stars, many like our sun. They revolve around the galactic center, at whose heart, most probably, is a massive black hole. Carrying Earth and the planets with it, the Sun takes 225 million years to complete one orbit of the galactic center. Lying in a spiral arm, the Sun is 2/3 of the way out from the center. Quite remote from the seething energy of the core, with its veil of gas and dust. Like the stars of our immediate neighborhood, the Sun is yellow, average, and middle-aged. And as astronomers discover more and more planets around other stars, the Sun is certainly not unique. This is our own backyard, the 9 planets of the solar system. Gas giants like Saturn and Jupiter, and 4 inner planets, rocky little worlds that include blue Earth. The spin of our tiny planet, an axis tilted by 23 degrees, and Earth's annual orbit of the Sun determine our view of the cosmos. That window changes night by night, season by season, latitude by latitude, all charted in this graphic guide to the heavens. Stars are grouped into patterns or constellations, often characterized in celestial mythology. With computer animations, familiar constellations, and pinpoint destinations, the night sky comes alive. Objects visible only in binoculars or telescopes, or best understood with graphics, are signposted by the nearest star or constellation line. As with all the planets of the solar system, Earth revolves around the Sun. Each orbit takes a year, shorter than Mars and the outer planets, longer than the 2 innermost. Imagine a line extending from Earth through the Sun to the background stars. During the year, as Earth orbits the Sun, so the stellar backdrop changes. We can't see the stars, of course, because the Sun's so bright. But if we could, this is the path the Sun would appear to take from May to September. Astronomers call the line the ecliptic. Looking in the opposite direction, in the evening this would be our view, a view that shifts from night to night. Season by season, the change is obvious. But over 24 hours, the shift is almost imperceptible, because the stars rise and set just 4 minutes earlier each day. In 3 months, a shift of 6 hours. Again looking toward the Sun, remember it's our annual orbit of the Sun that causes its apparent journey along the ecliptic. The stars through which it passes are the constellations of the zodiac. The ancients saw them as heavenly figures: Taurus the bull, Gemini the twins, Cancer the crab, and Leo the lion. Later in the year, after Leo, Virgo the virgin. Then Libra, the balance or scales, and Scorpius, the scorpion. Ophiuchus, the serpent-bearer, is ignored by astrologers, adding an extra constellation to the 12 used in horoscopes. Next, Sagittarius, the archer, Capricornus, the sea-goat, and Aquarius, the water-bearer. In the 4th and final season, Pisces, the fishes, Aries, the ram, and Taurus, the bull, where we started this cycle. The 12 signs of the zodiac used by astrologers have little in common with the 13 zodiacal constellations of modern astronomy. Astronomy is science. Astrology is not. The 8 innermost planets of the solar system orbit the Sun in roughly the same plane. The exception is the 9th, distant Pluto, with its eccentric orbit. This common plane means the innermost planets we see always appear on or close to the ecliptic, and they move quite differently through the sky to the stars. The workings of the solar system explain why planets don't feature in the star maps of this graphic guide. With their slightly elliptical orbits, the planets circle the Sun at different speeds. Jupiter, the outermost here, takes 12 years for an orbit. The innermost, Mercury, just 88 days. Venus and tiny Mercury are best observed shortly after sunset and just before dawn. Neither climbs far above the horizon, so tight are their orbits of the Sun. Mercury is difficult to see, barely clearing the skyline. But Venus, the most brilliant planet, can be bright enough to shine in daylight. Venus and Mercury lie between the Sun and Earth with its circling moon. The planets farther out, like Mars, Jupiter and Saturn, display the weirdest movements in the heavens, so-called retrograde motion. Once a year in the zodiac, the planet Jupiter hiccups in its normal west to east motion, with a little backward loop. The same happens with Saturn, here through 2 consecutive years. With Jupiter the example, the cause is the faster solar orbit of Earth. As it overtakes Jupiter, the planet appears to go backward. Then, as Earth swings toward the other side of the Sun, Jupiter goes forward again. The Moon. After the Sun, the brightest object in the sky. Both a fascinating partner and the curse of astronomers, denied the dark skies essential for the best observing. The Moon, our mysterious neighbour. Mysterious because the ancients must have puzzled at its monthly phases. The Moon has no light of its own. It merely reflects the sunlight, constantly illuminating half its face. In the 27.3 days of the lunar orbit, the amount of lit surface we see from Earth changes day by day, like this. The Moon isn't in the star maps of this graphic guide. As with those wandering stars, the planets, the Moon has a different dance to the stars of the cosmos. It's because we have the moon that we enjoy the greatest astronomical spectacular, a total eclipse of the sun. There'd be more if it weren't for the 5-degree tilt of the moon's orbit with respect to the plane of the ecliptic, here in green. During each orbit of Earth, the moon twice intersects the ecliptic plane, here and here. For an eclipse to occur, Earth, Moon and Sun must all be in line at an intersection. Imagine you, the viewer, are the Sun. As alignment approaches, here's the total eclipse. If the intersection is on the far side of Earth, the event is a lunar eclipse. A lunar eclipse works like this. Moving into the shadow of Earth, the moon turns blood red. Indirect light from the sun is bent and filtered by Earth's atmosphere and projected onto the moon. Lasting up to an hour and 3/4, a lunar eclipse is always seen on the night side of Earth. Now an eclipse of the sun, but because the moon's orbit is slightly elliptical, this eclipse isn't total. The moon's shadow doesn't quite reach us. The result is an annular eclipse. The moon, at its farthest from Earth, is too distant to fully obscure the sun. This time, the moon is closer in its orbit, close enough for the dark inner shadow, the umbra, to sweep Earth at supersonic speed. Such an alignment happens about 70 times a century. On Earth, the umbra is creating a total eclipse. The outer penumbra delivers a partial. For those in the shadow of the umbra, and with a clear sky, totality verges on the magical. As the moon creeps over the brilliant solar disk, this partial phase can last an hour and a half. The diamond ring. The moon is shutting off the sun. Then, as the last beams twinkle through the lunar mountains, Bailey's beads. And totality. It happens because the sun is 400 times larger than the moon, while the moon is 400 times closer to us than is the sun. Beyond the sun, the moon and the planets are the stars of this graphic guide. Stars that each night appear to journey through the heavens. But it's not the stars that are moving, it's our planet, a daily rotation on an axis hitched to the celestial poles. The pole star, Polaris, marks the north celestial pole. Around it, star trails reveal the rotation of planet Earth in this overnight exposure. The south celestial pole has no marker star, just the nearby constellation of Crux Australis, the Southern Cross. As Earth rotates, so the sky appears to circle the emptiness of the south celestial pole. We see the varying brightness of stars, and 2 blue patches, neighbouring galaxies to our Milky Way. Here's how to find the north celestial pole. Identify the Plough or Big Dipper, an easy pattern. It's part of Ursa Major, the constellation of the Great Bear. 2 stars point the way to the pole star Polaris. We've reached the north celestial pole. Our view is north from the mid-latitudes of the northern hemisphere. It's mid-evening. With Ursa Major, these are the circumpolar constellations, stars that circle the pole. From this latitude, they don't rise and set like most constellations. But they have their seasonal shifts. 4 minutes a night, 6 hours every 3 months. For the south celestial pole, string a line from Crux Australis, the Southern Cross, to Achernar, a brilliant star. The midpoint is the pole. A whole gaggle makes up the circumpolar constellations. Our view is south from the mid-latitudes of the southern hemisphere. It's mid-evening. These circumpolar stars don't rise or set, but they conduct their seasonal circuit. For the observer, whatever the season, only half the sky is visible from any point on Earth. In the Northern Hemisphere, this is the view from the mid-latitudes, the first zone featured in each of our 4 seasonal guides. Next is the Equatorial zone, the tropics, the second featured in our guides. The third is the view from the mid-latitudes of the Southern Hemisphere, from places like Australia and southern South America. We're in the Northern Hemisphere, looking at the northern sky. Our target is the pole star, Polaris. Viewed first at 40 degrees north, say from Washington, D.C., Polaris drops lower in the sky, the farther south we travel. At Panama City, just 10 degrees north of the equator, Polaris would be here. South of the equator, Polaris is gone. Instead, in this view to the south, we see the South Celestial Pole. The farther south we go, the higher the pole rises. Now, at about 40 degrees south, this is the view from Melbourne, Australia. Although the tilt of Earth is always 23 degrees, its axis hasn't always pointed to the celestial poles of today. It's because Earth wobbles like a spinning top. Known as precession, the main cause is the Moon's pull on the equator. The effect on the North Celestial Pole is to move it around a great circle. Once the North Star was Thuban. Today it's Polaris, and in 4,000 years' time, it'll be Alderamin. The whole cycle takes just under 26,000 years. As with maps of the world, astronomers divide the sky into a grid. Here, the celestial equator is drawn directly above Earth's equator. To the north, at 10-degree intervals, are lines of declination. It's the same to the south. They're like latitude lines. This line equals 0 longitude. It's called the first point of Aries. To the left, divided into hours, minutes and seconds, are lines of right ascension east, and the other side, lines of right ascension west. A reference grid that can pinpoint any celestial object. And there's a handy way to do it. The outstretched hand at arm's length measures off 15 degrees of sky, an hour's right ascension. The clenched fist is 10 degrees, again held at arm's length. The span of 3 fingers, close together, is 5 degrees. And finally, the little finger, set at arm's length against the heavens, is just 1 degree. But that's bigger than you think. In lunar terms, it's a lot of sky. By night, the moon may appear the largest celestial object, but it measures only half a little finger, half a degree. To get the best from stargazing, the observer needs a telescope, or at least good binoculars. Too much is missed by naked eye. For the new observer, better to buy binoculars with quality optics than a poor telescope. The investment will last a lifetime. Marked on every pair are numbers specifying magnification and lens size. These 10 by 50. The 10 indicates that this pair will give a 10-fold magnification of the image. The 50 is the size of the lenses, both 50 millimeters. Here, the eyepieces are marked 5 millimeters. That's the width of the exit pupil, the light beam from the eyepieces. The size you need depends on age. If you're under 40, the pupils of your eyes will dilate to 7 millimeters. If you're over 40, just 5. If you're young, you'll see best through an exit pupil of 7 millimeters, so use binoculars marked 7 by 50 or 10 by 70. Dividing the numbers gives the exit pupil. Compared with binoculars, telescopes are expensive. They must be solidly mounted on the likes of a rigid tripod. There are two sorts of telescope. This is a refractor. Light is collected by a lens and focused in the eyepiece. The minimum useful aperture is 75 millimeters. Telescopes with apertures greater than 100 millimeters are usually reflectors. Popular sizes are 150 and 220 millimeters. Light is collected by a primary mirror on the right, bounced to a secondary mirror, and diverted to an eyepiece at the side. The detail and color we see in an astronomical object depend on how we gather its light. The bigger the lens or mirror, the more light is concentrated on the retina. But the naked eye is poor at seeing color at night. Unaided, this is how we see the Orion Nebula, lower frame. It's still black and white through binoculars or a small telescope. A moderate telescope gives more detail, but only through the biggest instrument does Orion's glory emerge, and that coaxed by supersensitive imaging. Many of the images in this graphic guide come from powerful professional telescopes, like this one in the Andes. Or from here in Australia, where astronomer David Malin combines long-exposure photography with special processing techniques. He reveals the true colours of stars. In this case, the true colours and detail of his Orion Nebula. Huge instruments, like the Very Large Telescope in Chile, gather light as few stargazers can. Synchronized and combined with 3 others, this mirror equals a 16-meter eye. By comparison, orbiting 600 kilometers above, the Hubble Space Telescope has a modest mirror. But out here, it's untroubled by Earth's atmosphere. Hubble's brilliant pictures feature throughout this graphic guide. From our vantage point on Earth, and from above it, we've learned how to view the cosmos. But how do we measure its distance? Starting locally, our tiny planet is a mere speck against the Sun. The Sun has more than 100 times the diameter of the Earth. This local star of ours could swallow us 1,000,000 times over and still have room to spare. And here's another measure. Light from the Sun takes under 8.5 minutes to reach Earth. And there's the clue. Using the speed of light, 300,000 kilometers a second, astronomers measure distance. To the nearest star system, Alpha Centauri, it's 4.3 light years. In other words, it takes more than 4 years for the light from Alpha Centauri to reach us. In terms of the Milky Way, from the Sun to our galactic center is 30,000 light years. Finally, a preview of some objects we'll meet in the seasonal sky guides that follow. The spiral arms of this galaxy abound in nebulae. We're interested in the pinkish ones, clouds of glowing hydrogen gas. Like the Lagoon Nebula in the Milky Way, such clouds are starbirth regions known as gaseous emission nebulae. Another example is the Rosette Nebula. Emission means that the nebula emits its own light. The rosette surrounds a group of stars called an open cluster. An open cluster may be a few dozen stars, or hundreds scattered across 50 light years. The most famous open cluster is the Pleiades, or Pleiades. These are reflection nebulae, clouds of gas and dust reflecting coloured starlight. 2 more, beautifully reflecting light from embedded stars. Now to dark nebulae, not holes in space, but dense clouds of dust. On the left, the Cone Nebula, a classic dark nebula in brilliant surroundings. And here, the most famous dark nebula, the Horsehead. Next, planetary nebulae. This is the Helix Nebula, formed as a dying star expels shells of gas. Another, more complex, is the Cat's Eye Nebula. And even more complex, the Hourglass Nebula. A planetary nebula is a form of emission nebula. So too is a supernova remnant, here the Crab Nebula. Supernova remnants are the entrails of giant stars that have exploded. As with all emission nebulae, supernova remnants generate their own light. Like tiny outriders around the great disk of our galaxy, float some 150 globular clusters. They're bunches of ancient stars, some tightly packed with dense cores. Others looser. They may contain tens, even hundreds of thousands of stars. There could be 1 million in one of the largest globular clusters, 47 Tucani. Lastly, to galaxies. The blue patches in this time-lapse are the Magellanic Clouds, 2 satellite galaxies of the Milky Way. With no distinctive shape, they're called irregular galaxies. By contrast, Andromeda is a well-defined spiral galaxy and largest member of our local group. Beyond that group, an elliptical galaxy with a dusty band, known as NGC 5128. Still farther, this one is an edge-on spiral, its reference, NGC 4945. And another, NGC 4565. NGC means New General Catalogue. Even deeper into space, the Sombrero Galaxy is also an edge-on spiral. Here's an elliptical galaxy, M87. M is for Messier, the catalogue of a French astronomer. This is a face-on spiral, NGC 2997, 55 million light-years from home. And this, a barred spiral, NGC 1365, at 60 million light-years. The central bar also features in NGC 1300, at 75 million light-years. Most galaxies occur in groups, some with just 2 or 3 members. Others are vast, like the Virgo cluster, bustling with some 3,000 galaxies. A little more distant is the Fornax cluster, less rich in galaxies, but sporting some gems. Still farther, the Coma cluster, with more than 1,000 galaxies. And here, the distant Perseus cluster, a rich but faint array. These are the most remote galaxies ever glimpsed, 4 billion times fainter than stars we see by naked eye. Images from the Hubble Space Telescope. No matter we'll never glimpse them, for the cosmos is an endless journey of fascination, however we view it. The mid-latitudes of the Northern Hemisphere. From January to March, our viewpoint for the night sky. It's mid-evening, and we're looking north. We approach the crossroads of the northern sky, the 7 stars of the Plough or Big Dipper. The pattern is part of a bigger formation, the constellation of Ursa Major, the Great Bear. In mythology, the bear is a nymph transformed as punishment for an illicit love affair. Back with the Big Dipper, its stars lose their familiar pattern if we circle around them. This imaginary spaceflight reveals their varying distances from Earth. In the handle of the Plough or Big Dipper, a double star, Mizar, and its fainter companion, Alcor. Distant Alcor, here in animation, is quite far from Mizar. Big telescopes show Mizar has a much closer twin, and the same may be true for Alcor. From the stars Merak and Deux to Polaris, the North Star or Pole Star. Polaris is in Ursa Minor, the Little Dipper or Little Bear. Returning to the Big Dipper and close to Merak lies the Owl Nebula, M97. Through a moderate telescope, a shell of gas surrounding a white dwarf, a dying star. A little to the west of the Big Dipper is the Spiral Galaxy, M81, visible with binoculars, better in a small telescope. And just to the north, M82, an edge-on spiral. Both galaxies are some 10 million light-years from Earth. Northeast of our stellar signpost, another spiral galaxy, M101, 23 million light-years distant. It can be glimpsed in small telescopes. Extend a line from Merak and Deux through the pole star Polaris, and we arrive at Cassiopeia, nestling in the Milky Way, a vain mythological queen, banished to circle the pole star forever. Cassiopeia forms a W or M-shaped constellation. Here, star fields abound. Clusters like M52, visible in binoculars. And to the right, the Bubble Nebula, NGC 7635. Just north of Cassiopeia, the site of Tycho's star, a supernova of 1572. So brilliant was the outburst, it could be seen in broad daylight by naked eye. A white dwarf had exploded. Close by Cassiopeia, a radio image. In fact, the strongest radio source in the sky, Cassiopeia A. It's the remnant of a supernova of about 1660. Again, for a signpost, we go to the Plough, the Big Dipper. Draw a line toward the zenith, our overhead point, and we reach the yellow star, Capella. Capella is in the constellation of Auriga, the Charioteer. It's a large and prominent pattern. But it's also incomplete. The outline stops short of Alnath, a star now officially assigned to neighbouring Taurus. Nevertheless, Alnath still looks better in Auriga. To Capella, sixth brightest star in the heavens. Capella really is two stars, 42 light-years from Earth. They're giants, the largest 18 million kilometers across, 13 times the diameter of the Sun. Once more in Auriga, a triangle known as the Heidi, kids of the goat star Capella. Brightest is Epsilon Aurigae. And again it's more than one. Every 27 years this remote supergiant temporarily fades to half its normal brilliance. One theory is that it's eclipsed by a pair of companions shrouded in a dusty disk. Also in the Heidi, the binary star Zeta Aurigae. When the orange giant is eclipsed by its smaller companion, Zeta's combined brightness drops by 25%. Auriga straddles the Milky Way, its star fields visible in binoculars. Clusters like M38, M36, and M37. From two stars in the Plough, the Big Dipper, a line points the way to the star Murphak. It's in the constellation of Perseus, high in the western sky. Perseus, a hero of Greek mythology, lies in an abundant region of the Milky Way. Through binoculars or a small telescope, a pattern well worth sweeping. a wider perspective to discover two rather obscure patterns that occupy large areas high in the northern sky. The first is Camelopardalis, the giraffe. Set to the east of Perseus, Camelopardalis is devoid of bright stars. The adjacent constellation of Lynx is slightly better. It has one bright star, but cynics say you need the eyes of a lynx to make out the pattern. Our final vista of the northern sky. From the mid-latitudes of the northern hemisphere, this is our view to the south. One pattern dominates the sky, Orion, a constellation bedecked with magnificent nebulae and brilliant stars. Orion is the constellation of the hunter. He's killed by a scorpion and placed in the heavens, so that as Scorpius' slayer rises, Orion sets. Stars at the center form Orion's belt, and from the belt hangs a sword. But this is our earthly perspective. If we twice fly a circle through space, the 7 principal stars of Orion appear to change their relative positions. What they're really showing is their different distances from Earth. Turn Orion on its side and progressively defocus the camera, and here are the true colors of the stars. Most are hot and blue-white, indicating a surface temperature between 12,000 and 35,000 degrees. Upper left in Orion, the star is orange because its surface is much cooler. This is the realm of Betelgeuse, a giant 15 times more massive than the Sun. Placed in the solar system, Betelgeuse would stretch 3/4 of the way to Jupiter. At the tip of Orion's sword, a great wonder of the sky. To the naked eye, a misty patch. Through a big telescope, a cosmic sensation. M42, the great nebula in Orion. A cloud of dust and gas 30 light-years across. A place where stars are born. More than 4.5 billion years ago, our sun was spawned from such a cloud. A newborn star in a dusty cocoon, and another, just discernible. Animation shows how such a cocoon flattens into a disk around a young star. As the disk clears and consolidates, so planetary systems are thought to form. The belt of Orion hides another wonder, close to the star Zeta Orionis, also known as Alnitak. Alnitak is upper left, and the Flame Nebula next to it. In this, the most celebrated image of the cosmos, the Horsehead Nebula, a billowing cloud of dust invisible to all but the most powerful telescope. To the left foot of Orion, and the brilliant superstar Rigel. Rigel is 770 light-years distant and 60,000 times brighter than the Sun. A small companion, an ordinary star, is all but lost in Rigel's glare. A wider view to the south, and beneath Orion, Lepus, the constellation of the Hare. To the right, Eridanus, the celestial river, one of the largest and longest constellations. With Orion as our pointer, extend a line from the belt and we reach the bright star Aldebaran. Aldebaran is in Taurus. Taurus is a constellation of the zodiac, so the sun, the moon and the planets sometimes move against these background stars. Taurus is the constellation of the bull, Aldebaran his glinting eye. It's a useful shape, for the face of the bull is this V-shaped cluster of stars, the Hyades or Hyades, well seen in binoculars. Nearby another cluster, the Pleiades or Seven Sisters. Pronounced Pleiades in Europe, the naked eye sees 7 stars, binoculars dozens more. In fact, there are hundreds, hot, young and bright. Taurus again, and to the tip of the bull's horn, to the star Zeta Tauri. Close by, through a small telescope, a misty patch. But through a big telescope, the Crab Nebula, the debris of a supernova, the result of a gigantic stellar explosion. The supernova was seen next to a crescent moon in 1054. This a cave painting by the Pueblo Indians. Within the Crab Nebula, a remnant of the exploded star spins at 30 times a second, beaming radiation. It's a pulsar, or neutron star, matter jetting from its poles. Still in Taurus, we discover two interacting galaxies. A pipeline carries material from one to the other. They're galaxies NGC 1409 and 1410. A line from Orion's belt through Betelgeuse leads to the star Castor. Castor is white, while its near neighbour Pollux is orange. They're the twins of Gemini, another constellation of the zodiac. The respective stars form the heads of this celestial pair, supposedly the protectors of sailors. But fact is stranger than myth. In a small telescope, Castor appears as a double star. Spectroscopy reveals 6, 4 hot and white, 2 dull and red. Triple binaries, too close to separate, even with a big telescope. Again in Gemini, just visible to the naked eye, the cluster M35, hundreds of stars. Now from Gemini to NGC 2392, the Eskimo Nebula, a central dying star puffs off shells of debris. At the trusty signpost of Orion, this line via Betelgeuse points to Procyon, the brilliant star of Canis Minor, the little dog. Procyon is close, just 11.4 light-years from Earth, and with 7 times the luminosity of the Sun, Procyon shines bright. Who would guess at its dim companion, a dying white dwarf? Between Orion and Canis Minor, the constellation of Monoceros, the unicorn. We home in on a cauldron of starbirth, glowing gas, dark lanes of dust, and at the top, the star S Monocerotis. To the south, and invisible in small telescopes, the Cone Nebula. Set against luminous gas, hot young stars illuminate the cone. Finally in Monoceros, to the Rosette Nebula. Parts are visible with a small telescope. The full picture only in the most powerful instrument. Here a clutch of baby stars and a nest of glowing gas. East of both Monoceros and Gemini to the rather obscure stars of Cancer the Crab, another constellation of the zodiac. In Greek mythology, the crab was crushed by Hercules as he fought Hydra the sea serpent. The crab was compensated with a place in the stars. And what stars as we approach M44, the Beehive cluster. By naked eye, a misty patch. In binoculars, a swarm of 50 stars. In Gemini, from Castor and Pollux, extend a line to a small stellar group. It's the head of Hydra, the constellation of the sea serpent. Go on, and we reach Alphard, Hydra's brightest star. For the last pointer in the southern sky, the perspective widens to include the signpost of Orion. From the studs in Orion's belt, a line carries us to Sirius, the brightest star in the heavens. Sirius is in Canis Major, the big dog, with Canis Minor, the 2 hounds of Orion the hunter. Indeed, Sirius is the dog star, and in this telescopic footage there's a tiny companion, a white dwarf called the Pup. Our skies from the northern hemisphere. The mid-latitudes of the northern hemisphere, from October to December, our viewpoint for the night sky. It's mid-evening and we're looking north. Nights are colder and longer, and the daytime sun is lower in the sky. The same goes for the Plough or Big Dipper, its seventh star hidden beneath the horizon. The pattern is part of Ursa Major, the Great Bear. From farther north, of course, the whole constellation is visible. In Ursa Major, two stars point to the fifth brightest star in the heavens, Vega. Vega dominates Lyra, the constellation of the Harp or Lyre. Despite its proximity to the horizon, Ursa Major is an invaluable signpost. The stars Merak and Deux direct an arc to the pole star, Polaris. Polaris is in Ursa Minor, the constellation of the Little Bear. Curving onward, the arc reaches Cassiopeia, the mythical queen banished to the heavens for her vanity. But, lying in the Milky Way, the constellation is truly beautiful. Starfields abound, glorious through binoculars and small telescopes. One such is NGC 663, an open cluster near the star Rukbar. Slightly closer to Rukbar, M103, an irregular open cluster. And to the other side of Rukbar, NGC 457, a looser open cluster. From two stars in Cassiopeia, a line to Alderamin, brightest star in the constellation of Cepheus, husband of Cassiopeia and king of Ethiopia. Lower in the sky to a pattern coiled around the north celestial pole. This is Draco, the dragon, with Eltonin at the dragon's head, its brightest star. Northwest and spanning the Milky Way, the majestic constellation of Cygnus the Swan. The mighty star Deneb is the tail. Overhead and right from Cygnus, the zigzag of Lacerta, the lizard. Although its stars are inconspicuous, Lacerta lies partly in the Milky Way and boasts at least one splendor. NGC 7243 is a scattered open cluster of several dozen stars, and visible in small telescopes. Also in Lacerta, but clear of the Milky Way, an object seen only in the biggest amateur telescope. BL Lacertae isn't a star, but the bright nucleus of a remote quasar-like galaxy. Such phenomena, called BL Lax, can double their brilliance in a day. With the Milky Way strung above, we return to Ursa Major for a signpost. The stars Migres and Deux point to the sixth brightest star in the heavens, Capella. Capella is in Auriga, the charioteer. Straddling the Milky Way, Auriga is large and prominent. Again from Ursa Major, Fad and Deux return us to the Milky Way and Murphak, a supergiant. Through binoculars, Murphak sits in a brilliant scattering of stars, the abundant constellation of Perseus, the hero. In Greek mythology, Perseus slayed the Gorgon, Medusa, and rescued Andromeda, daughter of Cepheus and Cassiopeia. The handle of his sword marks two of the finest open clusters in the sky. Magnificent in binoculars, NGC 884 and 869 are just visible by naked eye. Higher in Perseus, to Medusa's evil eye, Algol, the star that winks. It does so because Algol is a binary, two stars whose combined brilliance appears to vary as they eclipse each other. Close to Algol, the Perseus cluster of galaxies. Visible only in large telescopes, they include a so-called Seyfert galaxy, possibly with a black hole, and jetting out material at near the speed of light. The Seyfert NGC 1275 has a brilliant quasar-like nucleus, but it's less energetic. Near the far western star of Perseus is M76, the Little Dumbbell Nebula, a shell of gas puffed off by an old sun-like star. It's just visible in a moderate telescope. The naked eye star, Minkib, or Xi Persei, illuminates NGC 1499, the California Nebula, again just visible in a moderate telescope. Northeast of Perseus, to the far right, and partly in the Milky Way, are the stars Castor and Pollux. They're the heads of the twins in the constellation of Gemini. Lower in the sky, the obscure pattern of Lynx, but with a small telescope, Lynx has some good double stars. To the southwest, the equally dim constellation of Camelopardalis, the giraffe. Within it, and at the very edge of naked eye visibility, the open cluster NGC 1502. Binoculars reveal some 45 stars. A final view of the northern sky. The panorama south has Orion, the constellation of the Hunter, far left. Next door is Taurus, the bull, another bold and distinctive pattern. To the west, Greek mythology suggests a group of stars born from the blood of Medusa. It's Pegasus, the winged horse, with the familiar square. Upper left in the square, the star that was once Delta Pegasi now belongs to neighbouring Andromeda, but we're headed just right of the square. This is 51 Pegasi, the first star like our Sun to be discovered with a planet. At half the mass of Jupiter, but far hotter, the planet whirls around the star in little over 4 days. 51 Pegasi is just visible by naked eye. So is this globular cluster M15, its collapsed core jammed with stars. The density is a puzzle, caused perhaps by intense mutual gravity or a black hole. Higher in Pegasus to NGC 7331, a spiral edge-on galaxy, visible on good nights through a moderate telescope. Close by, the same applies to NGC 7339 and 7332, two galaxies, although not obviously interacting, probably orbiting one another. Half a degree south, 5 galaxies known as Stephan's Quintet, best observed in the most powerful amateur telescope. South of Pegasus, and only seen in big telescopes, the Einstein Cross. Multiple images of the same quasar surround a central galaxy. Without the galaxy, light from the distant quasar would travel directly to Earth. But with the galaxy, its gravity creates a crazy lens. Light from the quasar is bent. Through the Hubble Space Telescope, this gravitational lensing gives us 4 images of the quasar, with the lensing galaxy in the middle. Finally in Pegasus, and only in large telescopes, the Seyfert galaxy, NGC 7742. Light from its brilliant core takes 72 million years to reach us. From their shared star, here called Alpheratz, the constellation of Andromeda unfurls from Pegasus. Andromeda, the princess rescued by Perseus, is home to the Andromeda Galaxy, M31. Like a big sister of the Milky Way, Andromeda is a spiral with 2 companion galaxies. By naked eye, on a clear night, it's the most distant object we can see. Upper right in Andromeda, the planetary nebula NGC 7662, one of the brightest and most easily seen by small telescope. Lastly in Andromeda, to the galaxy NGC 891. Although difficult even in a moderate telescope, this edge-on spiral is one of the best of its kind. Immediately beneath Andromeda and Pegasus are the faint stars of Pisces. Pisces is the constellation of the fishes, supposedly tied from their tails to the star Alpha Piscium. The pattern has 2 special features. The first is this circlet of stars. The second is that the Sun, the Moon and the planets all pass through Pisces as a member of the zodiac. Close to the upper fish lies the galaxy M74. Although the brightest in Pisces, it still needs a moderate telescope. East of Pisces is where the Sun used to move from south to north across the celestial equator. 2,000 years ago, the constellation of Aries marked the spring equinox. Today, this annual transition happens in Pisces. In mythology, Aries is the ram whose golden fleece was sought by Jason and the Argonauts. A wider view to locate a faint but distinctive pattern between Aries and Andromeda, the tiny constellation of Triangulum, the triangle. Its three main stars were well known to the ancients, resembling the Greek letter delta. To their right is M33, the pinwheel or triangulum galaxy. This face-on spiral, good in binoculars, belongs to our local group, although it's smaller than the Milky Way and Andromeda. In the arms of M33, stellar nurseries abound, like this region, NGC 604, with more than 200 hot and massive young stars. Still looking south from the northern hemisphere, the constellation of Cetus is center stage. Cetus is a large but faint pattern depicting a whale or sea monster. Supposedly it threatened Andromeda before Perseus saved her. Our target is Mira, the wonderful star, a pulsating supergiant orbited by a white dwarf. Varying from naked eye to small telescope visibility, Mira was the first long-period variable discovered. North of Mira, toward the head of Cetus, M77, with its bright active core, our closest Seyfert galaxy, and good in moderate telescopes. West from Cetus, to a zodiacal constellation, one of three linked with water. This is Aquarius, the water-bearer, named by the Babylonians who visualized a figure pouring water from a pitcher, an image still used today. To the left in Aquarius, and visible by small telescope, is the variable star R Aquarii. As a Mira type, it's a supergiant with a white dwarf drawing off material. Periodic fireworks result. To the right in Aquarius is NGC 7009, the Saturn planetary nebula, like this in the Hubble Space Telescope, reminiscent of Saturn in small instruments. Higher in Aquarius, to what appears as a fuzzy blob in binoculars, M2, a rich and compact globular cluster lying well beyond our galactic center. Finally, low in Aquarius, NGC 7293, the famous Helix planetary nebula, best in a moderate telescope. The helix is shells of gas expelled in the death throes of a star a little bigger than our Sun. At its heart, all that remains is a white dwarf. In the panorama south, the constellation of Eridanus, the river, meanders from Orion to the horizon. Upper right, two stars in the square of Pegasus point to the bright star Fomalhaut. Fomalhaut, just 22 light-years away, is in the constellation of Piscis Austrinus, the southern fish. We go closer to identify two faint and half-forgotten patterns. The first is Sculptor, for a reason as obscure as its stars, a sculptor's studio. The second is Fornax, the furnace, equally barren. From the northern hemisphere, the constellations south. The mid-latitudes of the northern hemisphere. From July to September, our viewpoint for the night sky. It's mid-evening, and we're looking north. Nights are short and warm, and at noon the sun is high overhead. The Plough, or Big Dipper, is easily spotted in these summer skies. The pattern forms part of Ursa Major, the constellation of the Great Bear, with its elongated tail. From a curve in the tail to Arcturus, brightest star of Deux, the constellation of the herdsman. Two more stars in Ursa Major, the pointers, signpost Polaris, the pole star. Polaris is in Ursa Minor, the little bear, and that curve from the pointers leads on to the star Gamma Cassiopeiae in the constellation of Cassiopeia. In mythology, Cassiopeia was a beautiful but boastful queen. Intriguingly, the Sun would be a yellow star in Cassiopeia if viewed from our nearest stellar neighbour, Alpha Centauri. Two stars in Cassiopeia direct us to Alpha Cephei, clearest star in the faint constellation of Cepheus, the king. Supposedly, Cepheus ruled Ethiopia, and Cassiopeia was his queen. At the top of the pattern, in a little trio, is Delta Cephei, a star that brightens and dims as it expands and contracts. It's called a Cepheid variable. Here's another, bigger and brighter, but pulsing more slowly. By comparing Cepheid variables, so-called standard candles, astronomers calculate distances in the near universe. With the Milky Way arching overhead to the east, we search for the dim stars of Draco. This straggling constellation of the Dragon is found best in summer. In Draco's coils, NGC 6543, the Cat's Eye Planetary Nebula. Like this through the Hubble Space Telescope, blue-green in a moderate telescope. Northeast of Draco, a pretty array straddles the Milky Way. It's the constellation of Perseus, the hero, with its bright star Murphak. Beneath is Capella, from neighbouring Auriga. And upper right, the pattern of Andromeda, in Greek mythology the beautiful daughter of Cepheus and his queen Cassiopeia. From the northern hemisphere looking north, the constellations of summer, Perseus. Andromeda on the right, her parents Cassiopeia centre and Cepheus to the left. And in the wider view, Ursa Major, Ursa Minor, Draco and Bootes. From the mid-latitudes of the northern hemisphere, the view to the south is dominated by three bright stars, Deneb, Vega and Altair. Strung high across the Milky Way, they form the Summer Triangle, not a constellation, but a seasonal signpost for observers in the north. To the right of the triangle, and outshone by Vega, its brightest member, lie the stars of Hercules. They're difficult to spot and are best identified by the box-like keystone of four central stars. South of Hercules is Ophiuchus, another dim constellation. Ophiuchus is entwined with a serpent. Its head, serpent's caput. Serpent's cauda, the tail. Our mission, however, is in Hercules, the constellation of the hero. At this season, the strong man is set upon his head. We approach the four stars of the keystone, all visible by naked eye: Epsilon, Zeta, Eta, and Pi. But Hercules only glitters through small telescopes, chief in its treasures, M13. This globular cluster is so bright, it's visible by naked eye on clear moonless nights. The same goes for another globular cluster, just up from the keystone, M92, at 26,000 light-years, slightly more distant than its neighbour. By an arm of Hercules, NGC 6210, a planetary nebula around a dying star. South once more to Ophiuchus. Like Hercules, Ophiuchus comes alive only through binoculars and small telescopes. Here the globular cluster M12, a rather loose collection of stars, and virtually the twin of M10 next door. Still in Ophiuchus, to RS Ophiuchi, a binary system that explodes every few decades or so. A dense white dwarf unsettles the system as material is drawn from the larger star, a case of recurrent stellar indigestion. Again in Ophiuchus, and visible in small telescopes, Barnard's star, a dim red dwarf that's so close it has the greatest apparent motion across the sky. As it passes the Sun in 10,000 years' time, Barnard's star will be our nearest neighbour. Ophiuchus is where the last supernova was seen in our galaxy. Called Kepler's supernova, it erupted here in 1604. Next door to Ophiuchus, in Serpens Cauda, M16, the evocative Eagle Nebula. At its heart, the pillars of creation. Pictured here by the Hubble Space Telescope, this column of gas and dust, 4 light-years high, is cool interstellar hydrogen, where stars are born. Although this is Hubble, the Eagle Nebula is a sight to behold in a moderate telescope. Still looking south from the northern hemisphere, the brightest star of the summer triangle, Vega, signposts its own little grouping, the pattern of Lyra. It may be small, but this constellation of the lyre, or harp, is prominent. Indeed, Vega is the 5th brightest star of all, with 50 times the luminance of the Sun and just 25 light-years away. Vega is bound to be bright. Immediately to its left is the smaller star Epsilon Lyrae, in fact a double star through binoculars. But in a modest telescope, the two are 4, a pair of binaries orbiting a common centre. Also in Lyra, and visible to the unaided eye, Beta Lyrae. It's a pair of peculiar stars, an eclipsing binary. They spiral hot gas into space. They're so close, mutual gravity makes them egg-shaped. Next to the odd couple, the Ring Nebula, M57, well seen in moderate telescopes. East of Lyra is Cygnus, the constellation of the Swan. Cygnus straddles the Milky Way and a dark lane called the Cygnus Rift. Actually looking like a swan, Cygnus is one of the few patterns to resemble the creature it represents. North of the swan's tail, Deneb, lies M39, a cluster of some 30 stars, easily seen in binoculars. At the swan's beak, the glorious double star, Alberio, or Beta Cygni, appears single by naked eye. Through a small telescope, the pair separate. They're so far apart they take over 7,000 years to orbit each other. To the tail again, and a familiar shape in a strange location. On the left, the North American nebula, NGC 7000, just visible by naked eye. And here, the duller Pelican Nebula. In a wing of the Swan is NGC 6826, the blinking planetary nebula. Through a small telescope, concentrate on the central star, and the nebula disappears. In the other wing of the Swan, to a supernova remnant, the Cygnus Loop, or Veil Nebula. The western part can be glimpsed in binoculars. The eastern segment needs a small telescope. In the neck of the Swan, to an X-ray source, Cygnus X1. A blue supergiant seems to be losing material to an object smaller than Earth, but with 7 times the mass of the Sun, probably a black hole, source of those X-rays on the right. finally in Cygnus, close to its central star, an exploding galaxy, Cygnus A. From the core, energetic particles shoot to this gigantic lobe. At the other side of the core, a second lobe. Invisible optically, this is a radio image. South from Cygnus, another bird, Aquila, the constellation of the Eagle. Like Cygnus, Aquila spans the Milky Way with its brightest star marking the southern tip of the Summer Triangle. Flanked by fainter sentinels, brilliant Altair. Altair spins so fast, it's 1/6 wider than its high, an effect of centrifugal force. Southwest of Aquila, Scutum, the tiny constellation of the Shield, has no bright stars. But this is a rich area of the Milky Way, and through binoculars, Scutum has the stellar vista of M11, the wild duck cluster. A little lower, another open cluster, M26, good in small telescopes. At the other side of Aquila, to the northeast, a gaggle of small constellations. The first, lower left, is Delphinus, the dolphin, a faint but distinctive pattern. Of its 5 main points, we focus on the dolphin's nose, a double star discernible in small telescopes. It's Gamma Delphini, a showpiece, with the right-hand star twice as bright as the other. Right from Delphinus is Vulpecula, the constellation of the Fox. An unremarkable pattern, it lies in the Cygnus Rift. But off the eastern tip, Vulpecula has the Dumbbell Planetary Nebula. Visible in binoculars, it's one of the finest in the sky. At the south of Vulpecula, the Coathanger cluster. Through binoculars, 6 bright stars in a row and an inverted hook. Sagittae, the diminutive pattern of the arrow, is the 3rd smallest constellation, but it's easy to spot in this fertile region. Close to its shaft is the loose globular cluster, M71, a fuzz in binoculars, stars in a moderate telescope. Southeast in the arrow, a recurrent nova. It's the blasting binary of WZ Sagittae. Our last look south from the northern hemisphere starts with Antares, brightest star of Scorpius, the pattern of the scorpion. Up through the wealth of the Milky Way are familiar constellations, the uppermost signposted by the Summer Triangle. But this southern panorama is incomplete. From the Milky Way at the horizon comes Sagittarius, the constellation of the Archer. To the left, Capricornus, the stars of the Sea Goat. And farther east, Aquarius, the water bearer. The mid-latitudes of the Northern Hemisphere, from April to June, our viewpoint for the night sky. It's mid-evening, and we're looking north. Some familiar constellations of the previous quarter are now higher in the sky, like the pattern of the Plough or Big Dipper, part of Ursa Major, the Great Bear. The 7 main stars of the Big Dipper appear fixed, but go back or forward 100,000 years, and their positions change. This movement is called stellar proper motion. The upper and lower stars move quite differently to the others, because the others are a cluster travelling through space with a common speed and direction. To the left, we focus on 2 stars in the bowl of the Plough or Big Dipper. These are the so-called pointers, a direction finder. A line from Merak through Dubhe finds the pole star Polaris. Polaris is the northernmost tip of Ursa Minor, the pattern of the Little Bear. Ursa Minor and Ursa Major are mythological characters banished to the heavens. The Great Bear, a nymph transformed for an illicit love affair, the Little Bear, her son, transformed for mistakenly hunting her. the god Jupiter swung the pair into the sky, and in the process stretched their tails. To the right of Ursa Minor, and snaking towards Ursa Major, Draco, the faint pattern of the dragon. 5,000 years ago, Draco's bright star Thuban was the pole star. It lies on the great circle through which celestial north travels once every 26,000 years. Yesterday Thuban, today Polaris. The shift is caused by Earth gently wobbling on its axis, like a child spinning top. We need a wider perspective to find a small pattern virtually overhead. It's tucked away near Ursa Major, above the handle of the plough or Big Dipper. These are the fields of the hunting dogs, the little constellation of Canis Venatici. We're looking for a galaxy, the first to have its spiral structure recognized. This drawing from 1846 is by an Irish astronomer. His subject, M51, the Whirlpool Galaxy. Visible in binoculars, stunning through the Hubble Space Telescope. Nearby to another spiral, M63, a misty patch in small telescopes, unmistakably the Sunflower Galaxy through the biggest. And close by, another patch in small telescopes becomes this compact spiral in big instruments, M94. Still in the north and looking north, we search for two rather obscure patterns. The first is above the northwestern horizon, Camelopardalis, the constellation of the giraffe. The second zigzags through much of the western sky, the dim stars of Lynx. Finally, in the northern sky, some signposts from Ursa Major. From two stars in the plough, the Big Dipper, a line extends to Regulus, brightest star in the constellation of Leo the Lion. But all we see here is the lion's head. Back in Ursa Major, an arc from the bear's tail curves overhead toward the southern sky. It leads to the bright star Arcturus in the constellation of Boötes, the herdsman. We're now looking south. The arc continues southward to Spica, a close binary with 2,000 times the luminosity of the Sun. Spica is in Virgo, the constellation of the Virgin. Looking south from the mid-latitudes of the northern hemisphere, this is the season of galaxies. For with the Milky Way well clear, the view beyond our galaxy is unobscured. With Regulus already glimpsed in the northern sky, all of Leo is visible to the south. In mythology, Leo is the lion killed by Hercules as one of his 12 labours. The 6 stars at the right, resembling a reverse question mark, are the sickle of Leo. At the left, forming the rear quarters of the lion, 3 stars make a triangle. Denebula is from the Arabic meaning tail. Just to the south of Leo, to a dim red dwarf, third nearest star to the Sun. This is Wolf 359. Occasionally it flares to twice its normal brightness. Leo abounds in galaxies, most good in small telescopes. Here, a galactic trio. One of them, NGC 3628, appears disrupted as it interacts with its neighbours, M65 and M66. Still in Leo and a little to the west, 3 more galaxies, M105 on the right, NGC 3285 upper left, and NGC 3379. Close by is this spiral galaxy, M96. Overhead from Leo is Leo Minor, the constellation of the Little Lion. It nestles between the rear paws of the Great Bear, Ursa Major, just visible above. To find sextans, the sextant, we look for Regulus in Leo. Sextans is directly south, an obscure pattern whose brightest stars are barely visible to the naked eye, but a good telescope reveals the lens-shaped spindle galaxy, NGC 3115. East of Leo to another dim constellation, Coma Berenices, supposedly the hair of an Egyptian queen. Here is the most famous edge-on spiral galaxy, NGC 4565, visible in small telescopes. Nearby is the Coma cluster, more than 1,000 galaxies. Sadly, most are beyond the range of small telescopes. Between Coma Berenices and Virgo, more than 3,000 galaxies, like M88, M91, M98, and M99, all spirals of the Great Virgo cluster. Overhead from Coma Berenices, in Canis Venatici, to the rich globular cluster, M3, a fuzzy patch in binoculars, like this in a big telescope. South now to Virgo, second largest constellation of the heavens. Virgo is the only female figure in the patterns of the zodiac. Spica is her brightest star. To the west is Porrima, or Gamma Virginis. Porrima is a double star. From Earth, it's sometimes hard to distinguish the two, but by 2015, they'll appear well apart. North of Porrima, and a return to the Virgo cluster. We're at the heart of this mighty galactic club. These are the galaxies of the local supercluster, to which our own galaxy, the Milky Way, belongs. As hazy patches, several dozen galaxies are visible in modest telescopes, but these images are from the most powerful professional instruments. The wonders of the Virgo cluster. Still in the Virgo cluster, the elliptical galaxy, NGC 4261. As a radio image, two jets stream from the core, evidence of a massive black hole at this galactic center. In animation, matter swirls inward from an accretion disk. Some matter jets at right angles to the disk, saved at the brink by the shock wave around the central vortex. The black hole consumes the equivalent of 40 Earths a day. Again, in the Virgo cluster, this elliptical galaxy, Virgo A, has an even bigger black hole, its jet captured by the Hubble Space Telescope. Here, in animation, the black hole is supermassive, swallowing the equivalent of 10 Earths an hour. It has the mass of 3 billion suns. Once more in Virgo, to the most incredible black hole of all. Visible in a moderate telescope, this is 3C273, the brightest known quasar. Quasars burn at the center of remote galaxies. So fierce and bright, they outshine the galaxies themselves. This radio image from 3 billion light-years away shows a jet streaking 150,000 light-years into space. Here's the jet, in visible light, shooting from the heart of the galaxy. Quasars, fueled by the hungriest black holes and consuming several hundred Earths an hour, are among the most luminous and powerful objects in the universe. Finally in Virgo, away from the main concentration of galaxies to M104, the Sombrero Galaxy. Visible in a moderate telescope, the Sombrero conceals another supermassive black hole. Southwest of Virgo, the squarish pattern of Corvus, the Crow. But we're headed northeast for the constellation of Deux and its brilliant star, Arcturus. Arcturus is a giant with the same mass as the Sun, but 25 times its diameter. Here's the Sun to scale. East from Deux to the Northern Crown. This is Corona Borealis, 6 main stars with the brightest Alphecca at the center. But we target a much fainter object, easy in binoculars. It's the giant star, R Coronae Borealis. At irregular intervals, it dims 1,000-fold as sooty clouds darken the atmosphere, only to clear again. Still in Corona Borealis, to a star visible with a small telescope. T Coronae Borealis, the blaze star, is so called because it's a recurrent nova. A white dwarf and its companion that once every century or so go bang. In the far west, a line from the sickle of Leo leads to Alphard, the solitary one. Alphard is the brightest star in the sprawling constellation of Hydra, the sea serpent. In mythology, Hydra was a 9-headed monster slain during the 12 labours of Hercules. Just south of its belly to NGC 3242, a planetary nebula called the Ghost of Jupiter. Still in Hydra, just south of Corvus, the globular cluster M68. A fuzzy blob in binoculars, stars become clear in a modest telescope. To the east and beneath Hydra's tail, M83, the southern pinwheel galaxy, visible in binoculars. The blue regions of the arms are full of hot young stars. Nearby, two galaxies distorted by their interaction, the larger NGC 5078, the other IC 879. Finally, around Hydra's tail, more galactic interaction. This is the warped disk galaxy, ESO 510 G13. The distortion of the dark disk may be the result of a close encounter with another galaxy, or the relic of a merged galaxy. Still looking south, we go east of Virgo, toward the split constellation of Serpens the Serpent. This is the reptile's head, Serpens caput. With the tail farther east, we close on the star Unu Kalhai, the serpent's neck, and nearby M5, one of the finest globular clusters, 12 billion years old. It's visible in binoculars. South from Serpens caput, to the least distinguished member of the zodiac, the dull stars of Libra. Libra, which looks more like a high-flying kite, is the constellation of the scales. They belong to the goddess of justice. As the only single green star in the heavens, Libra's brightest, Beta Librae, is also known as Zuban el Kamali. Alpha Librae is Zuban el Ganubi, Arabic names. The skies from the northern hemisphere. A wider view to the south, and beneath Orion, Lepus, the constellation of the Hare. To the right, Eridanus, the celestial river, one of the largest and longest constellations. With Orion as our pointer, extend a line from the belt and we reach the bright star Aldebaran. Aldebaran is in Taurus. Taurus is a constellation of the zodiac, so the sun, the moon and the planets sometimes move against these background stars. Taurus is the constellation of the bull, Aldebaran his glinting eye. It's a useful shape, for the face of the bull is this V-shaped cluster of stars, the Hyades or Hyades, well seen in binoculars. Nearby another cluster, the Pleiades or Seven Sisters. Pronounced Pleiades in Europe, the naked eye sees 7 stars. Binoculars, dozens more. In fact, there are hundreds, hot, young and bright. Taurus again, and to the tip of the bull's horn, to the star Zeta Tauri. Close by, through a small telescope, a misty patch. But through a big telescope, the Crab Nebula, the debris of a supernova. The result of a gigantic stellar explosion. The supernova was seen next to a crescent moon in 1054. This a cave painting by the Pueblo Indians. Within the Crab Nebula, a remnant of the exploded star spins at 30 times a second, beaming radiation. It's a pulsar or neutron star, matter jetting from its poles. A line from Orion's belt through Betelgeuse leads to the star Castor. Castor is white, while its near neighbour Pollux is orange. They're the twins of Gemini, another constellation of the zodiac. The respective stars form the heads of this celestial pair, supposedly the protectors of sailors. But fact is stranger than myth. In a small telescope, Castor appears as a double star. Spectroscopy reveals 6, 4 hot and white, 2 dull and red. Triple binaries, too close to separate, even with a big telescope. Again in Gemini, just visible to the naked eye, the cluster M35, hundreds of stars. Looking south from the mid-latitudes of the northern hemisphere, this is the season of galaxies. For with the Milky Way well clear, the view beyond our galaxy is unobscured. With Regulus already glimpsed in the northern sky, all of Leo is visible to the south. In mythology, Leo is the lion killed by Hercules as one of his 12 labours. The 6 stars at the right, resembling a reverse question mark, are the sickle of Leo. At the left, forming the rear quarters of the lion, 3 stars make a triangle. Denebula is from the Arabic, meaning tail. Just to the south of Leo, to a dim red dwarf, third nearest star to the Sun. This is Wolf 359. Occasionally it flares to twice its normal brightness. Leo abounds in galaxies, most good in small telescopes. Here, a galactic trio. One of them, NGC 3628, appears disrupted as it interacts with its neighbours, M65 and M66. Still in Leo and a little to the west, 3 more galaxies, M105 on the right, NGC 3285 upper left, and NGC 3379. Close by is this spiral galaxy, M96. South now to Virgo, second largest constellation of the heavens. Virgo is the only female figure in the patterns of the zodiac. Spica is her brightest star. To the west is Porrima, or Gamma Virginis. Porrima is a double star. From Earth, it's sometimes hard to distinguish the two, but by 2015, they'll appear well apart. North of Porrima, and a return to the Virgo cluster. We're at the heart of this mighty galactic club. These are the galaxies of the local supercluster, to which our own galaxy, the Milky Way, belongs. As hazy patches, several dozen galaxies are visible in modest telescopes, but these images are from the most powerful professional instruments. The wonders of the Virgo cluster. South from Serpens Caput to the least distinguished member of the zodiac, the dull stars of Libra. Libra, which looks more like a high-flying kite, is the constellation of the scales. They belong to the goddess of justice. As the only single green star in the heavens, Libra's brightest, Beta Librae, is also known as Zuban el Kamali. Alpha Librae is Zuban el Ganubi, Arabic names. Our last look south from the northern hemisphere starts with Antares, brightest star of Scorpius, the pattern of the scorpion. Up through the wealth of the Milky Way are familiar constellations, the uppermost signposted by the Summer Triangle. But this southern panorama is incomplete. From the Milky Way at the horizon comes Sagittarius, the constellation of the Archer. To the left, Capricornus, the stars of the sea goat. And farther east, Aquarius, the water bearer. East of both Monoceros and Gemini to the rather obscure stars of Cancer the Crab, another constellation of the zodiac. In Greek mythology, the crab was crushed by Hercules as he fought Hydra, the sea serpent. The crab was compensated with a place in the stars. And what stars as we approach M44, the Beehive cluster. By naked eye, a misty patch. In binoculars, a swarm of 50 stars. West from Cetus to a zodiacal constellation, one of 3 linked with water. This is Aquarius, the water bearer, named by the Babylonians who visualized a figure pouring water from a pitcher, an image still used today. To the left in Aquarius, and visible by small telescope, is the variable star R Aquarii. As a Mira type, it's a supergiant with a white dwarf drawing off material. Periodic fireworks result. To the right in Aquarius is NGC 7009, the Saturn Planetary Nebula, like this in the Hubble Space Telescope, reminiscent of Saturn in small instruments. Higher in Aquarius, to what appears as a fuzzy blob in binoculars, M2, a rich and compact globular cluster lying well beyond our galactic centre. East of Pisces is where the Sun used to move from south to north across the celestial equator. 2,000 years ago, the constellation of Aries marked the spring equinox. Today, this annual transition happens in Pisces. In mythology, Aries is the ram whose golden fleece was sought by Jason and the Argonauts. A wider view to locate a faint but distinctive pattern between Aries and Andromeda, the tiny constellation of Triangulum, the triangle. Its 3 main stars were well known to the ancients, resembling the Greek letter delta. To their right is M33, the pinwheel or triangulum galaxy. This face-on spiral, good in binoculars, belongs to our local group, although it's smaller than the Milky Way and Andromeda. Immediately beneath Andromeda and Pegasus are the faint stars of Pisces. Pisces is the constellation of the fishes, supposedly tied from their tails to the star Alpha Piscium. The pattern has 2 special features. The first is this circlet of stars. The second is that the Sun, the Moon and the planets all pass through Pisces as a member of the zodiac. Close to the upper fish lies the galaxy M74. Although the brightest in Pisces, it still needs a moderate telescope. The Equatorial Zone. From January to March, our viewpoint for the night sky. Mid-evening, and we're looking toward the northern horizon, at first glance a rather barren region. Camelopardalis the giraffe is much lower than from the northern hemisphere, so too the stars of Lynx. To the east and the constellation of Ursa Major, the Great Bear, including the Plough or Big Dipper. The North Star, Polaris, is now close to the horizon. From south of the equator, Polaris disappears altogether. Higher to a busier sky, and the stars of Leo the Lion, a pattern of the zodiac. Westward to Cancer the Crab, another zodiacal constellation. And also in the zodiac, the much bolder patterns of Gemini the Twins, and farther to the west, Taurus the Bull. Lower, via the shared star Alnath, lies Auriga the Charioteer with its bright star Capella. And finally, even lower, the stars of Perseus, the hero. The northern sky from the Equatorial Zone. With the Milky Way arching up to overhead, the southern sky from the Equatorial Zone. The sea serpent Hydra is just east of overhead, and tracking west with bright Procyon immediately above, the pattern of Monoceros the unicorn, and the handsome figure of Orion the hunter. At Orion's feet, Lepus the hare, and slightly to the east, brilliant Sirius in Canis Major, the big dog. Beneath is magnificent Puppis, the poop deck, and to the east on the other side of the Milky Way, tiny Pyxis, the compass. West of Puppis lies Columba, the constellation of the Dove. And heading southwest, one of the least conspicuous patterns, the two stars of Calum the Chisel. To the south of Puppis, Carina the Keel, with its famous star Canopus, the second brightest in the sky. Then northeast a little, to Vela the Sails. Before they were split, Vela, Carina and Puppis were the great ship Argo Navis, the biggest constellation of all. Next, to the best-known southern constellation, a pattern that's guided sailors for centuries, Crux Australis, the Southern Cross. And close by, the stars of Centaurus, the centaur, half man, half beast. For a signpost to the last constellation of the southern sky, we make for Orion and the bright star at the hunter's left foot, Rigel. Rigel is near the source of the celestial river Eridanus, an undistinguished pattern that meanders from near overhead right across the western sky. It ends close to the horizon with its only bright star, Achernar. Our tour of the equatorial skies. The equatorial zone, from April to June, our viewpoint for the night sky. It's mid-evening and we're looking north. The Plough, or Big Dipper, is now close to the horizon. So too the parent pattern of Ursa Major, the Great Bear. From an arc of 3 stars in the Bear's tail, a curve to Arcturus, one of our closer bright stars. Arcturus, just 37 light-years away, is the jewel in the constellation of Boötes, the herdsman. Next in these tropical skies, another pointer from Ursa Major. 2 stars in the Big Dipper, the Plough, aim at Regulus. Regulus, a multiple star and also known as Alpha Leonis, is the eye-catcher in Leo, the constellation of the Lion. A wider vista to search for Gemini, the twins. From the mid-latitudes of the northern hemisphere, the whole constellation is visible. Here, just the heads of the twins, Castor and Pollux, peep from the northwestern horizon. Like farther north, the skies from the equator at this season have little of the Milky Way. Closest bright star to the hazy band of our galaxy is Vega in the tiny constellation of Lyra, well to the northeast. Upward from Lyra, the heroic pattern of Hercules, the half-mortal, who became a god after performing his 12 labors. With the Milky Way visible only at the northeast horizon, our final northward panorama from the tropics. This is the view to the south from the equatorial zone. To the east, upper left, the stellar supergiant Antares in the constellation of Scorpius, the Scorpion. To the right and directly south, Centaurus, the Centaur. Its 2 brightest stars, Rigel Centaurus and Hadar, are the southern pointers. Beneath Centaurus, Crux, the famous Southern Cross, so beloved of sailors. It has a bright double star, A Crux. To the east of Centaurus, the tiny V-shape of Norma, the carpenter's set square. Close to Norma, 2 treasures. The first is Shapley 1, a planetary nebula surrounding a white dwarf, but visible only in big telescopes. The second is Menzel 3, a distorted patch in a moderate telescope, but well named the Ant Nebula through the Hubble Space Telescope. These are the death throes of a star like our Sun. To some larger patterns of the southern sky. Overhead is Spica, brightest member of Virgo, the constellation of the Virgin. And just beneath, the rough square of Corvus, the Crow, while from the west, with its star Alphard, comes the tail of Hydra, the sea serpent. Southwest now to three patterns that once formed the great ship Argo Navis. The first is Vela, appropriately named the constellation of the sails. To the right is Puppis, the poop deck, at this season disappearing beneath the southwestern horizon. And to the east, Carina the keel, third part of the old ship. Above them all, Antlier, the air pump, named after the invention of the Frenchman, Denis Papin. Within Antlier lies NGC 2997, a spiral with a small nucleus and sprawling arms. This faint but impressive galaxy is visible in a moderate telescope. The southern sky, seen now with the Milky Way. As we track toward the red star Antares in Scorpius, it's the starting point for a sweep along the hazy band of our galaxy. Through binoculars or a small telescope, the Milky Way offers some of the most delectable views in the equatorial skies. The mid-latitudes of the southern hemisphere, where daylight is shortened. The mid-latitudes of the southern hemisphere, where daylight is shortening and the nights are longer. From April to June, our viewpoint for the constellations. With the Milky Way far to the right, our mid-evening view is clear. Unimpeded by the haze of our galaxy, we see beyond, deep into the northern sky. To the west, the bright star Regulus dominates the pattern of Leo, a member of the zodiac. As such, this constellation of the Lion is often a backdrop to the Sun and its orbiting planets. A wider view reveals the Plough or Big Dipper digging a furrow on the horizon. A curve from three stars in the handle leads to the star Arcturus. Arcturus is the fourth brightest star of the night sky. It's also the brightest in Boötes, the constellation of the herdsman, and neighbouring Corona Borealis, the northern crown. Unlike most stars, the colour of Arcturus is perceptible to the naked eye as an orange hue. Onward from Arcturus, the curve from the Plough or Big Dipper targets Spica, a brilliant white star. Spica, with a surface temperature of 25,000 degrees and 260 light-years from Earth, is in Virgo. In this constellation of the Virgin, Spica is the ear of wheat in her hand. Westward for a pointer from the inverted question mark that forms the sickle of Leo. Two stars signpost the orange giant, Alphard. Alphard, the only bright star in the constellation of Hydra, the sea serpent, is well named the solitary one. Beneath Hydra, Corvus, the tiny constellation of the Crow. Within, and visible in a moderate telescope, the antennae galaxies NGC 4038 and 4039. They're the result of a titanic interaction, here in animation. The galaxies don't collide, but pass through each other, scattering stars into the shape of an insect's antennae. From the Hubble Space Telescope, images of the heart of the galaxies. They show a firestorm of starbirth, unleashed by the interaction. East of Corvus, Hydra and Virgo, to a member of the zodiac, the faint stars of Libra, through which the Sun passes in early November. Libra is the constellation of the scales, the balance supposedly held aloft by the goddess of justice. To the right, the broad pattern of Ophiuchus, the serpent-bearer. In mythology, Ophiuchus struggles with a snake, its head upside down to the west, serpent's caput, its tail to the east, serpent's cauda. Despite the drama, an unremarkable region. Finally, toward the horizon, to the fifth largest pattern in the heavens, the constellation of Hercules. Again, its stars are dim. Indeed, the northeastern sky at this season is rather barren. From the mid-latitudes of the southern hemisphere, our bearings south. Upper left, within the Milky Way, Crux Australis, the Southern Cross, and just beneath Carina, the constellation of the Keel, with its bright star Canopus. Above, Vela the sails, and to the southwest, the pattern of Pupis the poop deck, third component of the mythical ship Argo Navis. In the richness of Carina, and easy in binoculars, lies IC 2602, the open cluster of Theta Carinae, also known as the Southern Pleiades or Pleiades. Still in Carina, and just a colourless patch in moderate telescopes, NGC 3576. But apply a big telescope to this nebula of starbirth, and clever photography unlocks these real colours. The same goes for IC 2220, the Toby Jug Nebula, like a beer mug. It's a reflection nebula, lit by a bright red giant at the centre. In this abundant region of the Milky Way, Carina has more treasures. This, NGC 3293, an open cluster with a red giant set among hotter stars. And here, the Carina Nebula, NGC 3372, the most exquisite in the Milky Way and visible to the naked eye. Within, the Keyhole Nebula and brilliant Eta Carinae, good in binoculars, but through the Hubble Space Telescope, a superstar in tumult, a supernova about to happen. From Carina upward to Crux, the Southern Cross, with its two brightest stars, A Crux and Mimosa. Together with two neighbouring stars, here's the Southern Cross progressively defocused in a long exposure. It reveals the star's colours, which elude the naked eye. Close to Mimosa, or Beta Crucis, the open cluster of the Jewel Box, NGC 4755. And here's the Milky Way enveloping the stars of Crux. To the lower left, the Coal Sack, not a hole in space, but a dark nebula. East of Crux, the signpost to the Southern Cross, the pointers, Rigel, Cantorus and Hadar. They're part of Centaurus, the spectacular constellation of the Centaur. Rigel Cantorus is our target, properly known as Alpha Centauri. A single star by naked eye, Alpha Centauri is, in fact, twins and a red dwarf, at 4¼ light-years, our closest stellar neighbours. Next in Centaurus, to the rear hoof, and the Lambda Centauri cluster, IC 2944. The stars are visible in a small telescope, but not the dark globules or the pink nebulosity. Again, toward the rear leg of Centaurus, NGC 3918, the Blue Planetary Nebula, a bluish patch through a moderate telescope, but like this in the Hubble Space Telescope. Behind the shoulders of Centaurus, and easy with the naked eye, to the biggest and best globular cluster. It's Omega Centauri, 1 million stars, just 17,000 light-years from Earth. Nearby in Centaurus, and good with binoculars, the remarkable galaxy Centaurus A. Radio telescopes detect powerful emissions jetting from the galactic core, evidence maybe of a black hole. Close up, this dark lane could be the remains of a smaller galaxy that ploughed into Centaurus A and triggered a flurry of starbirth. The catalogue number, NGC 5128. Next door is the galaxy NGC 4945. Like Centaurus A, it's relatively close to us, but as an edge-on spiral, easily missed in a small telescope. Finally in Centaurus, and upward in the sky, to NGC 4622, the backward spiral galaxy, so called because it rotates in the same direction as its outer arm's trail. The cause may have been a collision. Just a blur in a moderate telescope, this image is from Hubble. Within the Milky Way and south of Centaurus, at the foot of Crux, the Southern Cross, lies NGC 5189, an intriguing feature of Musca, the tiny constellation of the Fly. The object is the spiral planetary nebula, the dying gasps of a star like our Sun. Why the expulsions are so chaotic puzzles astronomers. From Musca, south again to the Chameleon, a pattern as inconspicuous as its name suggests. But a large telescope reveals the Chameleon 1 complex, bright nebulae and hot stars close to the celestial South Pole. Northeast from the Chameleon, 3 main stars form Triangulum Australe, the southern triangle. By naked eye, an easily recognized pattern, although outshone by Alpha Centauri above. Between the two, the constellation of Cercinus, the drawing compass. The location of a Seyfert, a galaxy expelling gas at high speed and pictured here by the Hubble Space Telescope. Seyferts are thought to contain massive black holes. The Seyfert in Cercinus may be invisible to all but the most powerful instrument, but the glories of the southern skies are there for all. Swept through binoculars or a low-power telescope, the Milky Way is scattered with star clusters and bright nebulae. From April to June, a graphic guide to the heavens. The mid-latitudes of the southern hemisphere, where it's late summer and the nights are relatively short. From January to March, our viewpoint for the constellations. It's mid-evening and we're looking north. Dominating the northern sky, the stars of Orion. Inverted to visitors from the north, this is Orion correctly configured for observers in the south. If mythology has it wrong, with the hunter on his head, it's because the Greeks never dreamt of these southern skies. At the right of Orion's belt, to Alnitak, or Zeta Orionis, seen here lower frame with the famous Horsehead Nebula, a great dust cloud in silhouette. The Horsehead is detected only in the biggest telescope, but here, in Orion's sword, a nebula visible to the naked eye, albeit as a misty patch. But through the most powerful telescope, the glorious nebula in Orion. To the west of Orion, Eridanus, the river, flowing far out of view, and above Orion, the stars of Lepus the Hare. They help point us to IC 418, 2,000 light-years from Earth, the Spirograph Nebula. Spirograph is the fate of our Sun after it bloats to a red giant and sheds a nebula. Orion, our unfailing signpost. From his belt, a line extends towards the star Aldebaran, the lusty eye of Taurus the Bull. The story goes that the god Zeus, disguised as a majestic bull, fell in love with beautiful Europa. As she climbed on his back, he carried her off for his own, swimming from Phoenicia to Crete. Only the forequarters of Taurus are visible as he emerges from the sea. In the V-shape that forms his face, an open star cluster called the Hyades or Hyades. It's visible to the naked eye, as are the Pleiades or Pleiades just beneath. They're the most famous open cluster of all, commonly known as the Seven Sisters. Orion again, and a pointer through Bellatrix carries us to the bright star Capella. Capella is the jewel in Auriga the charioteer, an easily seen pattern sharing a star with Taurus. A line now from Orion's belt through Betelgeuse to Castor. Castor is a sextuplet, but appears only as a double star through a small telescope. In the pattern of Gemini the twins, Pollux is the brightest point. Castor is the white star immediately below its orange partner. In mythology, the god Zeus cast the twins into the sky so they would never be separated. A wider vista for a signpost. From Bellatrix in Orion through Betelgeuse we reach Procyon in Canis Minor, the little dog. Procyon is clear to the naked eye, but its fellow in the two-star constellation is a little fainter, the star Beta Canis Minoris. Higher in the sky to the obscure constellation of Monoceros, the Unicorn. Within the Crook, at its base, lies the star cluster at the heart of the Rosette Nebula. On the clearest nights, it's discernible in small telescopes. Close by in Monoceros to Trumpler 5, an ancient star cluster. Devoid of bright, short-lived youngsters, these dim stars simmer on the back burner. Nearby is Hubble's Variable Nebula. It changes appearance, due probably to passing dust clouds. Moving eastward from vivid Gemini and obscure Monoceros, we encounter another indistinct pattern, the stars of Cancer, best found with binoculars. Like Gemini, Cancer is in the zodiac, one of the few claims to fame for this constellation of the Crab. From Castor and Pollux in Gemini, the line to a small group of stars that form the head of Hydra the sea serpent, just visible with the naked eye. Onward to the star Alphard, the solitary one, so called because of the lack of bright objects nearby or within the entire straggle of Hydra. A wider aspect, to seek direction from Orion. By extending a line upward from the belt, we reach Sirius, brightest of all stars. Sirius is the dog star, animated here with its pup. Just 8.7 light-years from Earth, Sirius is the beacon of Canis Major, the big dog. And there's another attraction. It's as wide as the moon. M41, a cluster of 80 stars, clear by naked eye. From Canis Major we move up to the stars of Puppis, the poop deck, and home in on a patch of light easily seen in binoculars, M46, a cluster of more than 100 stars, plus, lower right, a planetary nebula. Our last panorama north from the southern hemisphere. From the mid-latitudes of the southern hemisphere, the view to the south has a nautical touch. First, Puppis, the constellation of the poop deck. Then Vela, the constellation of the sails. And thirdly, down below, Carina, the constellation of the keel. At its western tip, the second brightest star in the heavens, Canopus. As we close with Puppis, our sights are set for a faint but fascinating globule, simply known as CG4. Several light-years across, it's a dust cloud being destroyed by radiation jetting from energetic stars, a cosmic jellyfish in retreat. To 4 stars, sometimes mistaken for the Southern Cross. The shape is right, but the false cross is larger, more symmetrical, and less bright than Crux Australis, the real Southern Cross. As it hoves into view, compare the Southern Cross, the stars of Crux, that adorn the flags of several nations. Next to a fabulous supernova remnant spread across the borders of Puppis and Vela. Spanning 40 degrees of the sky, the Vela supernova remnant is the entrails of one or more ancient explosions. But so diffuse is this stellar debris, only large telescopes can see it. Eastward now to NGC 3132, the 8-burst or Southern Ring Planetary Nebula, good in small telescopes. Back with the 3 constellations of the ship, we close on Carina and then head southeast for the most exquisite nebula in the Milky Way, NGC 3372. Abounding in young stars, some the brightest and most massive in the galaxy. This is the Carina Nebula, and it's visible to the naked eye. At the western tip of Carina, brilliant Canopus needs no telescope. To the south and rather outshone is Pictor, the faint constellation of the painter's easel. At its western tip, Beta Pictoris is easy by naked eye. But when the star is masked out, this is what appears, a dusty disk. Here in animation, the disk seems to be warped. The culprit could be a planet orbiting the star. The clue is from the Hubble Space Telescope. To the northwest of Pictor, and visible in binoculars, lurks the red dwarf, Capitan Star. It is so close, just 12.8 light-years, that its swift progress through the cosmos can be detected. South of Pictor, Dorado, the stars of the goldfish, and at their southeastern tip, the bright patch of the large Magellanic Cloud. This time-lapse of stars circling the southern celestial pole has the large Magellanic Cloud upper right, with the small Magellanic Cloud beneath. They're satellite galaxies of the Milky Way. The large cloud links Dorado with Mensa, the constellation of the Table. To the northeast is Volans, the pattern of the flying fish. And in the western sky, Eridanus the river runs out at Achernar. Brilliant Achernar is a pointer to the elusive pole of the southern skies. Imagine a line strung from Achernar to the Southern Cross. The starless midpoint is the pole. And just below, the pattern of octans, our final constellation. From January to March, a graphic guide to the heavens. The Equatorial Zone, from October to December, our viewpoint for the night sky. It's mid-evening, and we're looking north. Bright stars abound. There's Deneb in Cygnus the swan, and sweeping east the stars of Lacerta the lizard. Cepheus the king is below, with his queen Cassiopeia in the Milky Way. Next, Camelopardalis, the giraffe. Then Auriga, the charioteer, sporting brilliant Capella. The stars Castor and Pollux are the twins in Gemini. At this season, the Milky Way swings low. Above the Milky Way, the northwestern sky is dominated by the stars of Pegasus, the winged horse, with its distinctive square. Sharing a star with Pegasus, Andromeda, daughter of Cepheus and Cassiopeia. Overhead, Pisces, the constellation of the fishes. To the right, Aries the ram. And just below, Triangulum, the tiny triangle. This is a wonderful time for observers. The sky is bedecked with brilliant stars. One of the most glittering constellations straddles the Milky Way. With the bright stars Murphak and Algol, it's Perseus, the hero. Southeast is Taurus, with Aldebaran marking the eye of the bull, while upper right, Orion has the stars Rigel and Betelgeuse. From the tropics, the constellations to the north. The view south from the equatorial zone is virtually clear of the Milky Way. Far to the east, Sirius, brightest of all stars, marks Canis Major, the big dog. The bright star Canopus is to the west. Canis Major just nuzzles the Milky Way, as do the stars above. With Rigel and Betelgeuse the brightest, this is Orion, the hunter. Rigel is close to the source of the meandering constellation of Eridanus, the river. Running all the way to Achernar, its brightest star, most of Eridanus is rather faint. From the sixth largest constellation to five much smaller. The first is Columba, the pattern of the dove. To the right, the two stars of Calum, the chisel, and farther right, Horologium, the constellation of the clock. Beneath is Dorado, the goldfish. And next door, Reticulum, the reticle, an old instrument for measuring star positions. Leaving the large and small Magellanic Clouds just above the horizon, we move toward the southwestern sector of the sky. At the top, the bright star Fomolo marks Piscis austrinus, the southern fish. Lower left, the triangle of Hydrus, the little water snake, and above, with Achernar between, Phoenix, the mythical bird. Below, two more birds, Tucana, the pattern of the toucan, and Grus, the crane. To the southwest, the pattern of Indus, named in honor of native North Americans. To complete this southern panorama, we identify 4 constellations in the upper southwestern sky. The first bears little relation to its name, Fornax, the barren pattern of the furnace. Upper left, Cetus, the whale or sea monster, is a more convincing depiction. But Sculptor, the sculptor's studio, is as abstruse as its stars. To the right, however, Aquarius, the water-bearer, has been a recognizable figure since Babylonian times. Our tour of the equatorial skies. The mid-latitudes of the southern hemisphere, where it's late winter and the nights are long and cool. From July to September, our viewpoint for the constellations. As we look north in the mid-evening, 3 bright stars command the lower stretch of the Milky Way: Deneb, Vega, and Altair, points of the winter triangle. A configuration rather than a constellation, the triangle is an invaluable guide for the observer. To the west, immediately left of Vega, the faint stars of Hercules, best recognized by the square-like keystone at the center. Unusually for the southern hemisphere, Hercules is the right way up. He holds the multi-heads of Hydra, slain in one of his 12 heroic feats. A wider vista for another faint pattern. Above Hercules, Ophiuchus, the serpent-bearer. Supposedly, Ophiuchus is struggling with a snake. The inverted head, serpent's caput to the left, the tail, serpent's cauda, here on the right. But our target is in Ophiuchus, the planetary nebula NGC 6369, the Little Ghost. Clear in a moderate telescope, this star is dying. Nearby is M19, a distant globular cluster, but visible in binoculars. Flagged by Vega, Lyra is lower in the Milky Way. To the east, Cygnus the Swan, marked by Deneb. Of the 3 stars in the triangle, Deneb is the faintest. It's much farther away. Right from Deneb, in a wing of the Swan, the Cygnus Loop or Veil Nebula. Visible in binoculars, it's the entrails of a star that went supernova 15,000 years ago. From Cygnus, upward to Altair, beacon of Aquila the Eagle. As third point of the triangle, Altair shines bright, but the nearby planetary nebula NGC 6751 is seen only in the biggest telescope, the celestial eye. Northwest of Aquila is Scutum the Shield. Here, just right of centre, is M11, the wild duck open cluster. Good in binoculars, it's an array of some 200 stars. Lower down in the Milky Way, between Aquila and Cygnus, 3 neat little patterns. To the right, Delphinus the dolphin. To the left, Vulpecula the fox. And in the centre, Sagitta the arrow. With the Milky Way evenly dividing the northern sky, we begin our trek through the northeastern quadrant. From Altair and 2 neighbouring stars in Aquila, a line extends to the brighter stars of Capricornus. Capricornus is a constellation of the zodiac through which pass the Sun, the Moon and the planets. As the pattern of the sea goat, Legend has it that the god Pan, fleeing a monster, leapt into a river. His head became the goat, his rear a fish. Just above the fishy tail, the globular cluster M30. Visible in small telescopes, M30 has a dense, collapsed core. During the long nights of winter and the relatively pollution-free atmosphere of the southern hemisphere, what better season to sweep the glories of the Milky Way through a good pair of binoculars? After all, the show is free. Finally, looking north from the south, two constellations. Pegasus, the winged horse, dull but easy to spot with its central box, and Aquarius, the water-bearer. From the mid-latitudes of the southern hemisphere, the view south is centered on the Milky Way. With Antares, its brightest star, this is Scorpius, a constellation of the zodiac. To keep them apart, the creature who supposedly killed Orion, Scorpius the Scorpion, is placed at the other side of the sky, to its victim, the hunter. Set mainly in the Milky Way, Scorpius offers rich pickings, here the resplendent stars of the tail. But toward the head, Antares steals the show, a supergiant shedding a cloud of particles into space. Next door on the right, the globular cluster M4, and upper left, the star Sigma Scorpii, a magnificent region and visible in binoculars. Above the tail of Scorpius, a couple of open clusters. M6 is well named the butterfly cluster when viewed in binoculars. M7 is brighter and visible by naked eye. Next in Scorpius, to a small globular cluster. M80 needs a moderate telescope to resolve its stars, and there are several 100,000, held together by gravity. Close to a claw of Scorpius is the strongest X-ray source in the sky. The cause? Scorpius X1, a neutron star stripping material from its companion. Northeast of Scorpius, Sagittarius, another pattern of the zodiac. Lying in the direction of our galactic center, Sagittarius abounds in starfields and nebulae. In this constellation of the Archer, half man, half beast, we take aim for M17, an emission nebula known variously as the Omega, Swan, Horseshoe, Checkmark, or Lobster. Clear in binoculars, in the wider view M17 is set in a sea of stars. As we travel down the Milky Way, a purple blur lower right. In close-up, it's M20, the Trifid Nebula, crossed by dark dust lanes and visible in binoculars. Sagittarius has one of the finest globular clusters, M22, and as one of the closest, it's bright enough to spot by naked eye. Through binoculars, it's wonderful. So too is any sweep of the Milky Way, this one leading to M8. In close-up, M8 is the Lagoon Nebula, a vast gaseous cloud, clear by naked eye. Still in Sagittarius, to NGC 6522, a small, faint globular cluster, visible only in large telescopes. It's the midpoint of a window, amid dense star fields, through which astronomers try to glimpse the galactic center, 30,000 light-years away. In this star-packed region, not the window, but a dark cloud called Barnard 86, and above it, the open cluster, NGC 6520. Finally, the holy grail of Sagittarius is obscured by dust clouds and brilliant star fields. In infrared, this is as close to the galactic center as we can see, the supermassive Pistol Star. From Sagittarius, we leave the splendours of the Milky Way for some quieter constellations. The star Fomalhaut flags the pattern of Piscis austrinus, the southern fish. On the right, the simple shape of Microscopium, the microscope. And below, Indus, like a boy with a football. Westward, toward the tail of Scorpius. And appropriately, to really enjoy the dim stars of Telescopium, a telescope is required. Just above, the same applies to Corona Australis, the southern crown. But it hides a twin jewel, the reflection nebulae, NGC 67, 26 and 27. They're lit by young stars. Southward is the constellation of Ara, to the Greeks and Romans, a sacrificial altar. Ara is in the Milky Way and rich in vistas. This one, NGC 6188, an emission nebula. Also visible in binoculars, Ara boasts the globular cluster NGC 6397. And the Stingray, the youngest known planetary nebula, a Hubble image. Still in the Milky Way, but much closer to the horizon, we target the Southern Cross, Crux Australis, and enveloping it, Centaurus the Centaur, with its bright star Rigel Kentaurus. Almost touching, to the north, Lupus, the stars of the Wolf. And to the east, Triangulum Australi, the easy shape of the Southern Triangle. Just below Rigel Kentaurus, the star Hadar directs us through the Southern Triangle to the Peacock star. As the football of Indus, the Peacock star is in fact the brightest point in Parvo, the constellation of the Peacock. North in the pattern is a spiral galaxy like our own, NGC 6744, best in moderate telescopes. Lower in Parvo and needing a good telescope, two interacting galaxies, the larger NGC 6872, the other IC 4970. The foreground star is unconnected. In these southern skies of winter, a final constellation. Near the bright star Achernar lies Tucana, the pattern of the toucan. The star and the bird are markers for a faint blue patch, a satellite galaxy of the Milky Way, the small Magellanic Cloud. It's visible by naked eye on a clear night, with the globular cluster 47 Tucani on the left. From July to September, a graphic guide to the heavens. The mid-latitudes of the southern hemisphere, where nights are warming and shortening. From October to December, our viewpoint for the night sky. It's mid-evening and we're looking north. The Milky Way is a misty band on the horizon. Immediately above, with its great square, is Pegasus, the winged horse. Alpheratz is the star lost to neighbouring Andromeda, the beautiful princess. Low in Andromeda, and equally beautiful, M31, the Andromeda Galaxy. Visible by naked eye and the largest in our local group, Andromeda resembles the Milky Way. Above Pegasus and Andromeda lies Pisces, the Fishers, a constellation of the zodiac. Here in the southern hemisphere, Pisces is the site of the autumn equinox, where the sun crosses the celestial equator from south to north. 2,000 years ago, it happened in Aries, but Earth's slight wobble has shifted the transition. Beneath Aries, Triangulum, the triangle. And lower still, Perseus, the hero who saved Andromeda. Above is Aldebaran, brightest star of Taurus the Bull, with the Pleiades or Pleiades to the left, the most famous open star cluster in the sky. Two stars in the square of Pegasus signpost Fomalhaut. Just 22 light-years away, Fomalhaut is twice the size of the Sun and 13 times as luminous. As the beacon of Piscis austrinus, the southern fish, Fomalhaut is well named the fish's mouth. For in the disk that surrounds the star, a mouth could be opening, where material clumps into planets. Down from Piscis austrinus is Aquarius, the water-bearer, a constellation of the zodiac. Right from Piscis austrinus, the dim pattern of Sculptor, supposedly a sculptor's workshop. Although its stars are of little interest, Sculptor has two fine examples of edge-on galaxies, astronomically fairly rare phenomena. The first is NGC 55. Good in binoculars, a big telescope can resolve individual stars. Another galaxy, oblique rather than edge-on, is the Cartwheel. It looks this way because an intruder careened through, creating a great ripple of stars. The culprit, possibly a small galaxy to the right. The Cartwheel needs a large telescope. Unlike Sculptor's second edge-on spiral, NGC 253, at about 10 million light-years, it's fine in binoculars. Still looking north from the southern hemisphere, we close on a faint set of stars that include Deneb Catos and Myra. This is Cetus, the constellation of the Whale. Upward and right is Fornax, the furnace. Despite its name, nothing glows in Fornax, but powerful telescopes reveal galaxies. This one, NGC 1316, is a cannibal devouring other galaxies. It's a member of the Fornax cluster, a compact group 60 to 65 million light-years distant. Many are elliptical galaxies, but not this one, NGC 1365, a classic barred spiral, some 200,000 light-years across. Lastly, in the northern sky, a couple of important constellations. The first is the Hunter, Orion, with its bright stellar markers, Rigel and Betelgeuse. The second is often overlooked because of its faintness and length, Eridanus, the river. At this season, it runs from way overhead to near Orion's star Rigel. In a loop of the river is the galaxy NGC 1300, a barred spiral, but visible only in larger telescopes. Nearby, the same goes for NGC 1232, twice as wide as the Milky Way. The northern sky. This is the panorama south from the mid-latitudes of the southern hemisphere. To the east, the sky is dominated by the stars Canopus and Sirius. As the brightest star of all, Sirius marks Canis Major, the big dog. Likewise, Carina, the ship's keel, is flagged by Canopus. In between is Puppis, poop deck of the legendary ship Argo Navis. Below are its sails, Vela. Supposedly, Jason sailed Argo Navis in search of the Golden Fleece. Before it was divided, Argo Navis was the biggest constellation. High in the heavens, two bright stars, Rigel and Achernar, mark either end of Eridanus, the celestial river. Part of it meanders overhead into the northern sky. Beneath is Columba, in mythology the dove released by Jason and the Argonauts. To the right, Calum, the two stars of the chisel. And still farther right, Horologium, faint and obscure, the constellation of the clock. It honours the pioneering of the pendulum clock by the Dutch astronomer Christian Huygens. Horologium has at least two treasures, the globular cluster NGC 1261, whose stars can be resolved in a moderate telescope, and at the eastern end of the pattern, the galaxy NGC 1512, a magnificent barred spiral. Discernible in binoculars, this image is from Hubble. West from Horologium, high in the sky, is the stellar beacon of Fomalhaut. Between Fomalhaut and Achernar is Phoenix, the mythical bird, but more like a moored riverboat. In this sector of the southern sky, stargazing is like birdwatching. With Phoenix at the top, the water bird Grus is nearby, the pattern of the crane. Below, toward the horizon, is Pavo the peacock. And completing the flock, Tucana, the constellation of the toucan. Upper right, Fomolo marks Piscis ostrinus, the southern fish, while below, honouring native North Americans, is Indus. This is the region of the Magellanic Clouds, two misty patches that are satellite galaxies of our Milky Way. With the large Magellanic Cloud on the left, we head for its lesser companion. On a good night, the small cloud is visible by naked eye, but there's no missing the object on the right. Unconnected with the cloud, this is the globular cluster 47 Tucani, second largest and second brightest of its kind. At this season, the Magellanic Clouds make excellent observing. They're either side of Hydrus, the triangle of the little water snake. Above the large cloud is Reticulum, the reticle, a device for measuring star positions. A wider view shows the goldfish, Dorado, with its tail flicking the large cloud. Toward the head, NGC 1566, a Seyfert galaxy. The brilliant nucleus is like a quasar, but less energetic. Mensa, the table, is a bookend with Dorado as they unfold the large Magellanic Cloud and its 10 billion stars. Through binoculars and small telescopes, the LMC reveals clusters and individual stars. Pink nebulae of hydrogen gas are regions of stellar birth. The biggest is the Tarantula Nebula. Lower right, some massive stars destined to go supernova. And here, the largest, hottest and most massive stars ever seen. In 1987, a supergiant exploded in the LMC. For weeks it could be seen by naked eye. These are its shock waves, the first ever photographed. Years later, this is the remnant of that cosmic flash. The LMC, our companion galaxy, is quite a showcase. This graphic guide to the heavens is complete. The Equatorial Zone. From July to September, our viewpoint for the night sky. It's mid-evening and we're looking north. Three prominent stars catch the eye: Deneb, Vega and Altair, corners of a triangle. Not a constellation but a seasonal signpost as we navigate the heavens. We set course west from the triangle, to the left of the Milky Way and brilliant Vega. Here are the faint stars of Hercules, the mythical hero. Above and equally dim, Ophiuchus, the serpent-bearer. The serpent is either side. Serpens cauda, the tail, Serpens caput, the inverted head. Downward to the northwest, the bright star at the left is Arcturus, our marker for Boötes, the constellation of the herdsman. Heading east, the Milky Way sweeps upward to the triangle. Beneath Vega is Draco, the coiled pattern of the dragon. And to the east, partly in the Milky Way, Cepheus, the constellation of the king. Next door, within the Milky Way, his beautiful queen, Cassiopeia. High above, the constellations of the triangle, Aquila, Lyra and Cygnus. And to the east, Pegasus, the winged horse. With the Milky Way arching to overhead, this is the view south from the Equatorial Zone. First, and splendid to sweep with small telescopes, Scorpius, the pattern of the scorpion. To the left, Sagittarius the archer, like Scorpius, a member of the zodiac. And farther east, a third zodiacal constellation, Capricornus, the sea goat. A little lower, with Fomolo, its starry beacon, is Piscis Austrinus, the southern fish, and to the right, the stars of Microscopium, the microscope. The southern constellations, unseen by the ancients, have less mythology than northern skies. Here, for instance, Native Americans are honoured in the pattern of Indus, the Indian, lower left. There's the telescope, Telescopium, and just above, the semicircle of Corona Australis, the southern crown, and toward the horizon, Ara the altar, nestling in the Milky Way. Finally, looking south from the tropics, a flock of 4 exotic birds. Flying east of Indus is Grus, the constellation of the crane. Southwest of Indus, Pavo, the peacock. In the far east, Phoenix, the mythical bird that rose from its ashes. And lastly, Tucana, the constellation of the toucan. Our tour of the equatorial skies is complete. In the nightly theatre of the heavens, there's more to stargazing than the stars, the planets, and the moon. There are special acts, celestial vagabonds whose unpredictability makes them all the more exciting, cosmic show-offs such as meteors, asteroids, and, most famously, comets. Comets come from beyond the planets, exotic wanderers that for weeks, even months, can steal the show. Visitors like Halley's Comet, which appears just once in 76 years. Comets are the nomads of our solar system. Some travel on random elliptical orbits, hurtling among the planets. Kamikaze comets plunge into the sun. Others just graze its surface. To understand comets, we must travel back nearly 5 billion years to the birth of the solar system. From a primeval nebula of gas and dust, the sun first coalesced. Then, from the heavier elements, the inner planets formed, solid little worlds like Earth and Mars. As the sun grew hotter, it generated a solar wind. Upon it were carried lighter elements. They formed the outer planets, gas giants like Jupiter and Neptune. And far beyond, a third of the way to the nearest star, settled a vast cloud of icy debris. Like a shell enveloping the planets, it's so diffuse you could pass through without noticing. This is the Oort cloud, where comets incubate. Every so often, one is dislodged from the equilibrium of Oort by a twitch in the gravitational interplay between the Sun and its neighbouring stars. Thus begins a tumble toward the planets, the comet relentlessly drawn inward by the Sun. Tails of gas and dust develop as the comet reaches the inner solar system. Ices vaporize. They stream off as fluorescing gas, millions of kilometers through space. All of this from a nucleus that might be no bigger than a football stadium. The tails only exist within the inner planets as the comet bathes in the warmth of the sun. And the gas tail always points away from the sun, blown backward by the solar wind. As it swings round the sun, this comet is returning to the cold outer depths, where its tails will disappear. From Earth, comets seem to hang motionless in the sky. In reality, they're travelling at many kilometres a second. But such are the stresses of the inner solar system that a comet nucleus may break up. With several fragments now streaming material, the tail can flare magnificently. In the wake of comets come shooting stars, properly known as meteors. As Earth intersects the trails of comets, dust burns up in our atmosphere, and meteors shower the sky. For a second or two, even a tiny grain can spark the heavens. Larger fragments, often originating from asteroids, produce fireballs, and if they survive to the surface, they become known as meteorites. Set in silver at the base of a black structure called the Khaba is possibly the most famous meteorite of all. In Mecca, at the time of the Hajj, millions assemble at this birthplace of Muhammad. Like Muslims throughout the world, the pilgrims pray toward their sacred stone, believed to be a gift to Abraham from the Archangel Gabriel. But there's a more prosaic view. Some scientists suggest the stone is one of the countless missiles that have pocked our planet since it was born. In other words, a meteorite burnt black by atmospheric friction as it careened to Earth. Australia, a land of contrasts. Beyond the urban fringe lies a vast and open continent. With its arid climate and undeveloped landscape, the outback is a mecca itself for those who seek traces of meteorites. These are the Henbury craters, dug by a meteorite that had broken into a clutch of missiles. And this is Wolf Creek, blasted by a similar-sized projectile that remained intact. The crater is almost a kilometre across. The impactor was the size of a large house and probably metal. Were it less substantial, even a rock 20 stories high, it would have vaporized in the atmosphere. Wolf Creek is 300,000 years old. Gossa's Bluff is older, 140 million years, and 22 kilometers wide. Arizona, and another pockmark in the desert. This is Meteor Crater, gouged by a lump of nickel and iron 40 meters wide. The crater is well over a kilometer. 50,000 years old, it still speaks of cosmic energy. And that energy keeps coming. In 1972, this space rock, twice the size of the Arizona impactor, was caught on camera. Luckily, it skipped off the upper atmosphere and back into space. 1992. During high school football on America's East Coast, a fireball. It fragmented, and some chunks were recovered as meteorites. Here's the incident from Pittsburgh. Siberia, 1908. This projectile, 60 meters wide, didn't reach the ground. It exploded in the atmosphere with the energy of a nuclear bomb. Over 2,000 square kilometers of uninhabited forest was flattened. Had this happened over New York, millions would be dead. As our partner in space, the Moon is testimony to Earth's vulnerability. Lifeless and barren, no ocean, nothing hides these lunar craters, each one the print of an impact. The Moon has some 30,000 craters, uneroded by wind or water, a pristine record of wax from space. Per square kilometre, Earth takes as many hits. Strip away our atmosphere, our seas, our vegetation, and all geological movement, and this would be our planet. And were it not for Jupiter, Earth would take far more knocks. Jupiter, here with one of its many moons, acts as a shield to the inner planets. Comets that pass too close are captured by Jupiter's Herculean gravity. This one, comet Shoemaker-Levy 9, was pulled from its elliptical orbit around the Sun. The comet, a fragile mix of ice and grit, was drawn to within 50,000 kilometers. It paid the price. Jupiter tore it into more than 20 fragments, and that was just the beginning. Shoemaker-Levy 9 was to stage a celestial showpiece. The comet was to plunge into Jupiter and carpet bomb the soupy atmosphere. From its perch in Earth orbit, the Hubble Space Telescope revealed a string of pearls. And because they were discovered well over a year before the event, astronomers had time to prepare. They'd watch as the multiple hearts of a comet hit a planet 1,300 times bigger than Earth. July 1994, and in New South Wales, the Anglo-Australian telescope was zeroing in. The week of the comet was at hand, and Shoemaker-Levy was performing brilliantly. As scientists had calculated, more than 20 pieces of grit and ice hurtled into the gas giant. Some were as big as mountains. But because the impacts were on the far side of Jupiter, just out of sight from Earth, observers had to hold their collective breath as the planet's spin brought the site of each impact into view. Patience and preparation were rewarded. Day by day, these heat-sensitive images displayed the aftermath of each impact. More than 20 major collisions at 60 kilometers a second. Some were bigger than expected. In Australia, astronomers awaited a grand finale.
Okay, Dave. Okay.
Oh God. It's gonna be bright.
It was an astrofest. Front row seats at a celestial premiere with a nail-biting climax.
And then you'll see at the bottom of the image, one of them will get particularly bright, sort of down the bottom, at the very edge.
The impacts had come thick and fast. Each comet fragment had a letter. Tonight's vigil was for fragment W. David Crisp of California's Jet Propulsion Laboratory was team leader. As W approached Jupiter, tension mounted. Would the comet end with a bang or a whimper?
Yes,
It was a dazzler, a signal so bright the astronomers had to protect the telescope's delicate sensors.
Close down just a touch, Frank. Down to 2.3 probably.
16.
And now for the picture of the blast.
Wow!
Whoa, got it! Very dramatic.
That evening, Crisp's team had captured the best image taken on Earth. The string of pearls a month before collision, with fragment W in the ring. Impact time predictions had been spot on. And so had imaging. From Earth, here's a plume rising 1,000 kilometers above Jupiter's horizon. and from a spacecraft, the actual impact of fragment W and the resulting plume. For months afterwards, Jupiter sported its scars, and they could be seen through the smallest telescope. Were this to happen on Earth, the result would be catastrophic. The dark crescent in these pictures is a shockwave as large as Earth itself. Imagine if Shoemaker-Levy 9 had hit us. Long ago, another comet swung close by Jupiter. It too, like Shoemaker-Levy, had its orbit forever changed by the gravity of the giant planet. That comet was Halley. Today it travels on a long elliptical orbit that carries it out beyond Neptune and back again for a spin around the Sun. Thanks to Jupiter, Halley is locked into a 76-year cycle. It last came our way in 1986. It's due back in 2061. Our understanding of comets began with Halley. More than any other, it's helped unlock the mystery of their origin. The story begins in the 17th century with the English astronomer Edmund Halley. Halley's friend and compatriot, Isaac Newton, the great physicist and mathematician, developed the theory of gravity. Bodies in space, he deduced, didn't travel in straight lines. Instead, their motion was bent by the attraction of others. In 1680, Newton observed the motion of a comet. He worked out that it wasn't traveling in a straight line, but in an orbit around the Sun. So he suggested that a comet with a small enough orbit might be seen again and again. To test the idea, Edmund Halley analysed the sightings of 24 comets. Two important observations emerged. First, 3 of the sightings were separated roughly by the same 76-year interval. Second, these same 3 comets seem to have virtually identical orbits. Could they be one and the same comet, a regular visitor? If so, the next return should be in 1758. Sure enough, on Christmas Day 1758, long after Halley's death, the comet reappeared. It was named Halley's Comet. The revelation allowed astronomers to trace the comet back through time. One of these Chinese tomb drawings confirms Halley's appearance a century or two BC. A coin struck in memory of Julius Caesar also bears an image of Halley. It had been seen in the emperor's youth. This, from 648, is what people called a broom star. It's the same comet. In 1301, the Italian painter Giotto made Halley's comet the Star of Bethlehem. Halley wasn't seen that first Christmas, but some astronomers have suggested another comet led the wise men on their journey. By the time of Halley's appearance in 1910, the world of advertising had caught up with history's most famous comet. Early 20th century scientists greeted the return of Halley with a new tool, photography. But the pictures lacked detail. The comet withheld its secrets. 3/4 of a century later, Halley's comet was back. This was its space-age debut. In 1982, although still invisible optically, Halley was detected electronically. Then, through telescopes in 1983 and 84, Halley appeared to loop the loop, an effect of Earth's path around the Sun. By late 85, as it passed through Taurus, Halley could be seen in binoculars. A tail developed in December, and the comet was visible by naked eye. In January 86, the northern hemisphere had its best views. Halley was then lost for a while behind the sun, before reappearing in the skies of the southern hemisphere. Observers had magnificent views from late February to mid-April, twin tails quite discernible. But the show was almost over. Halley had begun its return to the outer planets. Before it disappeared, however, the comet was investigated and probed as never before. From Earth and from space probes, data galore. Here, a head-on shot with spirals of gas trailing into space. The best images were recorded in the southern hemisphere. From the Chilean Andes, these show Halley after it rounded the sun. And this from the unpolluted skies of Equatorial Africa, a fuzzy cloud called the coma clearly visible as it shrouded the comet's nucleus. A curved tail of dust that appeared yellowish to the naked eye. And a straight tail of gas fluorescing blue over millions of kilometers. Another view from Africa. And for the first time, scientists did more than merely observe the comet. They reached out to it. As Halley sped past, an armada of robot spacecraft raced to intercept it. The most ambitious was a European probe named Giotto. Giotto was going for the closest of close encounters. It was to fly right through the inner coma, the cloud of dust and gas that surrounds the nucleus. And there was the nucleus. Like a peanut, a lump of primeval matter 16 kilometers by 9. Through the glare and fog, this was the very face of Halley. Vaporized by the heat of the sun, gas vented from cracks in the surface at 20 tons a second, dust at 10. The coma, fed by the jets, was well over 1 million kilometers across, bigger even than the sun. Giotto's transmission was knocked out with little more than 1,000 kilometers to go, but the probe had revealed a hardened shell of carbon black over an icy interior. From Earth, Halley put on its best show as it pulled away from the sun. Photographed over several months, the comet's tail lengthened and shortened day to day. Its overall brilliance fluctuated too. Astronomers attributed the variations to the solar wind, to changes in the composition of the comet's surface, and to the rotation of the nucleus. From the deep chill beyond Neptune to its tour of the Sun, Halley's surface had heated to over 90 degrees Celsius. In the late 80s, as Halley receded, so its image faded. Then suddenly, in 1991, it brightened. Could the comet have collided with something? We'll find out in 2061. By 1994, as it headed out past Saturn, Halley's comet was a few specks on a photograph. As we've seen, comets can originate in the Oort cloud, but some, like Halley, come from closer in, from just beyond the farthest planets. It's a region called the Kuiper Belt, and when Halley began tumbling inward, it was lucky. Instead of falling into the sun, Halley swung round it. But that means Halley is captive, locked in a vast ellipse that will take it round the sun again and again. At 76 years, Halley's orbit is relatively short. Longer period comets arrive from farther out, from the Oort cloud. Comets like Hale-Bopp, the most spectacular of recent times. Hale-Bopp, which appeared in 1997, has an orbital period of several thousand years. Here in close-up, Hale-Bopp's nucleus was 40 kilometers wide. It swirled gas and dust. They streamed from the hemisphere heated by the sun, switching on and off as the nucleus rotated. At its closest to the sun, Hale-Bopp shed 1,000 tons of dust every second. Little wonder there's less and less of a comet each time it passes the sun. Unlike comets, asteroids are from closer to home. Like a planet that never coalesced, they form a ring between the orbits of Jupiter and Mars, the asteroid belt. Made of sterner stuff than comets, asteroids are rock and metal, debris from the birth of the solar system. Within the belt, asteroids are harmless, but accidents happen. Collision, or a jolt from Jupiter's gravity, and an asteroid is knocked from its orbit. Drawn inward by solar gravity and with a nudge from Mars, this space mountain is now a projectile. 65 million years ago, this is believed to have happened. 10 kilometers of rock and metal were on a collision course with Earth. It was doomsday for the dinosaurs. Earth suffered a cosmic winter and mass extinction. At least 100,000 dislodged asteroids cross the orbit of Earth. 2,000 are big enough to cause us problems. This one is Eros, 40 kilometers wide. So real is their threat to Earth that NASA commissioned a probe to Eros to analyze and image the asteroid from every angle. In 2001, the probe landed on Eros, the better to make its acquaintance. Were we hit by Eros, nothing. No life on Earth would survive. The worry is that for every asteroid plotted here, 20 or more are yet to be discovered. So what could we do if one were headed our way? It's still science fiction, but we could build a parabolic mirror. Towed into space, it could concentrate reflected sunlight on an intruder and scorch it off course. In another concept, giant pods might close with an enemy asteroid and attach to its surface. They would release supersails that caught the solar wind and tugged the intruder away. Or how about this device? Like a celestial outboard motor, it could shunt the object to a safer course. But suppose there was too little warning. A space rock would hit us in weeks. Would we go for the nuclear option? It would be a last resort, either as a standoff blast or a direct strike. Who could predict if it would save the world?